Hello guys, thank you very much for joining in. We are going to be starting out with this chapter, machine learning models. Okay, and there are two new chapters which have been added to your FRM Level 1 curriculum. Okay, and these two chapters are very different from the previous chapters that you have seen, not even closely related to your VAR and all. The intention of giving you the understanding about these two chapters is that because the industry is moving towards AI, machine learning, so you should know some basics about it. So chapter is covering the basics itself, but the basic is slightly heavy. Okay, so the purpose that I'm going to fulfill in this chapter is that I'll be running a PPT wherein I'll try to run a simple example to make you understand things as much easy as possible. Okay, so first of all, when you hear the word machine learning, what do you think kya ho raha hai? Machine language. Okay, what else? Any idea? What is machine learning as per you? One understanding could be that machine is looking at some data, trying to understand the data, learning from that data, so that it can increase its understanding about the data. Okay. So idea is that there is some algorithm. When we say machine, it is basically an algorithm. Okay. Algorithm means it's a code. Okay. That code is created in such a way that it is not going to perform only one activity. For example, if you run a code in Excel VBA macro, okay, that you want to copy a file and put it into some drive, it will only perform that duty. Barabar hai? But when we talk about machine learning algorithm, it is going to learn on its own. That is the idea. Okay, so let us before we go into this paragraph, I want you to look at this first slide. Okay, and I'm assuming everybody is able to see it. So what exactly is machine learning? It's a computer's way to learn from the data. Very simple. And why are we using machine learning? This is an important point. So when you look at huge data, big data, किसी ने सुना है big data? Okay, big data का मतलब क्या है कि when you get variety of data, which can be slightly not so cleaned. For example, social media का Twitter data, wherein when you type on Twitter 160 words, बराबर? So in that way, you will not be able to get a meaningful sense of the data. When you have so much information, because when you're dealing as an organization, as a bank, you have internal communication through chats, through emails. Your customers are coming on your chat bot and they are asking certain things. They're calling you also. So there is a variety of data, variety of various forms of data and huge data available. But as a human being, it will be very difficult for you to understand what is the pattern in that data. That is where the machine learning concepts comes into picture. Okay, so to identify hidden rules from a pile of information, and this becomes very important for us because when we are looking at big data, which is handling really huge amount of data, machine will help us to identify those patterns, some hidden things which we cannot process because we have our own challenge in terms of processing things. Okay, next is complex relationships. Okay, certain things which you might not be able to see immediately or directly from the data. So when you do a linear regression, you know, by looking at the data, you might get some sense, because when you do a scatter plot, तुमको कुछ समझ में आता है, you get some understanding ना, कि whether my dependent variable is able to explain something about my, whether my independent variable is able to explain something about my dependent variable. But suppose the data is so complex, it is of so many variables, it would be very difficult for you to understand which variable is actually explaining what. Then machine can help you to do things. Certain complex relationship which are normal, a process will not be able to identify. Okay, so and this part, this is also written in your book explicitly. So whenever we use traditional approaches, so linear regression is one such approach. Okay, because when you're running, suppose I'm running a linear regression, I'm taking an example of linear regression because I am assuming that you'll be able to connect it better. So when you do a linear regression, you have a dependent variable. Suppose my dependent variable was sales of ice cream, and I am the researcher and I want to predict sales of ice cream. So I will take a variable, say temperature. Why am I taking temperature? Because I have some belief previously that temperature might be able to explain this. Okay, so whenever in a traditional context, a researcher will have some belief, some understanding about what might be happening. He will take the data, he will try to test that. Barabar? Ye logic samjha? You might have an understanding that, okay, temperature increase is going to increase my sales. If you have that belief, you will take the data and you will verify your claim. Barabar? That is traditional. But when we talk about machine learning, even if you do not have any understanding, just put the data. Obviously, you need to have the code. The system will be able to identify those hidden patterns or things which is not connected to any of your historical belief. ये समझ में आया? Clear है? So So I'm just connecting the dots now. Data, when you're using traditional method, okay, it is basically dependent on some theory which is already there in your mind. Okay, but when we talk about computer, this machine learning part, it is not bounded by that notion. It is not bounded by that notion. So if I give you a very basic example, I'm running a simple regression where I'm talking about dependent variable ice cream of sale and temperature, even though there is some independent variable humidity, which is not there in the model. I'm running this regression. I will never come to know that humidity is the actual, what do you say, explaining part, because it is not taken in the model. Okay, but when you look at machine learning, they will try to give you input so much huge data, it will try to find those variables which you never thought is actually impacting. Clear hai yahan tak? Okay. So in a very simple language, what is machine learning doing? It's a super smart computer which is basically trying to use a lot of data, trying to find new things. Okay. Now, if I go to the book, read this first paragraph. Everybody, please read this first paragraph. Now, what is happening in that paragraph? Okay, machine learning represents techniques where model recognize data pattern, like I said, from practical applications, real life incidents they will pick up. Okay, and if you have extremely large amount of data, which is big data, this approach, which is machine learning, is going to give you a lot of flexibility and use wide range of specification. Now, over here, wide range of specification means what? Okay, I'll talk about both the things, flexibility and wide range of specification. If I'm running a linear regression, what was the assumption of linear regression? That the relationship between dependent and independent variable should be linear. Agar relationship non-linear hai, if the relationship is non-linear, your model will break. Over here, it is not dependent on anything. It will find things, even if there is a non-linear relationship, even if something new is there, hybrid version, it will also find. Try to give you that answer. Clear? So it has wide variety of things which a normal standard linear models will not be able to capture. Okay, flexibility in the sense, it gives you the opportunity to identify that, okay, there might be a scenario that suppose India's GDP is dependent on 100 variables. So it will first identify those 100 variables, and within that 100 variables, which are the most important, it will also tell you that. Okay, so it gives you flexibility as a researcher. Next, under classical statistics and econometrics, okay, I'm also covering the text because thoda bahut text mein thoda sa alag tarike se diya hai. Okay, it is driven by the data generation process. Okay, first two lines. Kindly read the first two lines. Okay, so what was the data generation process? If you remember simulation chapter, when I want to do a simulation, I have to first describe the data generation process. Means I have to describe what is the distribution. Is it normal? Is it log normal? Or uske baad I used to go and do the entire analysis. So if you read the first two lines, what they're saying, whenever you look at traditional approach, there is some theory or some logic in your mind which is going to run, because you're running the model to test whether the theory is right or not. Barabar? For example, ice cream of sale, is it dependent on temperature? I can go and test it. I can take the data and run a linear regression. Okay. So analyst is going to choose the model, okay, or any algorithm and he will run some parameters and he will test the significance. I hope you're able to connect. What are the parameters? Parameters means your B0, B1 in your linear regression. What is this significance? Significance means when you run a model, you basically go and test whether the model is good or not. So there are different ways to check it. R-square, you can do hypothesis testing, right? So ultimate aim is to create a model and to test whether the model is good enough or not. Next, the data must use the result to determine if the data support the expected outcome. What is this expected outcome? So whenever you do a traditional model, you have an understanding in your mind. You run the entire model and you check whether the model is giving the same answer which was there in your mind, which was your expected outcome. ये समझ में आ रहा है सबको? Clear है? I'm purposely going very slow line by line because in the book थोड़ा सा mix करके दिया है उन्होंने. Okay. On the other hand, the model will not require any hypothesis form. Means, if you remember the chapter hypothesis testing, what was hypothesis? A statement. So before you run the hypothesis testing, you have to make a statement that, okay, this is what my belief is. And then you test the belief by doing the hypothesis testing. Barabar? So everything is dependent on that belief. Over here, there is no hypothesis. Clear hai? Okay? Now, lot of your financial theories, okay, like if you read this line, machine learning functions well with a lot of financial theorem, does not dictate the choice of variable. What is this choice of variable? That means, suppose if I want to identify, like I said, GDP of India, what are the factors which are going to impact the GDP of India? You might be able to tell one or two things, but exact factors, it will be very difficult for you to tell. Even if you run linear regression, multiple regression, first step is to identify which variable is actually impacting. So machine learning may just put on everything, every data that is available in the market, okay, and then on the basis of that, it will be able to identify these 10, 15 important chapters which can explain your variable. Then you can do further step. So machine learning mein, the line I'm just explaining that line, what is happening? It is not driven by what variables you have already chosen. It is by when you give the data, it will find the variable itself कि ये explain कर रहा है. आपने जो बताया वो नहीं. The variables you have told जरूरी नहीं कि वही explain कर रहा हो. Okay, so when you give data to when you are running a machine learning logic, when you give ample amount of data, it will find the variables which are actually impacting the model. And how is it different than the traditional? If you connect back to linear regression, you have to first define the independent variable. आपको बताना पड़ता है temperature is my independent variable, humidity is my independent. Then you run the model. Over here, no such thing is happening. The variables also can be found from the data. Okay, I'll give you a very simple example which is related to AI based. Okay, so some time back, Facebook had a model, okay, that will determine whether people will fall in love based on their chats, Facebook chats. तो उनका number of chats increase होता है. And they started predicting, and their status change happens. Samjha? So such kind of things. You never know what is the variable which is going to impact, because normal models will not be able to tell you this. Machine learning will be able to tell you this. Okay? Okay? So machine learning provides a lot of flexible functional forms. That means it can capture complex non-linear data points. Okay? If there is any interaction between variables, which means if suppose there are 2-3 variables which are connected to each other, okay, and they are explaining something. If you go back to linear regression, there was a problem called multicollinearity. Wherever, so we said now multicollinearity is a problem. But over here, your model will still be able to perform well if there is connections between your variables. Variable means independent variables, which are explaining your what you want to find. Clear hai yahan tak? Okay, which differs from a normal linear regression model. Okay, over here in the last part, they have last 3-4 lines. They have just talked about that explanatory variables, independence, normal distribution. ये सब चलता है conventional model के लिए. Means when you run a conventional model, traditional model, in a lot of models you need to have an understanding whether the model is based on normal distribution, whether the model is based on log normal. If you have assumed normal and the data is different, it will create an error, right? So you have to make a lot of adjustments when you're doing a conventional model or a traditional model. In machine learning, the focus is only on prediction, whether the final outcome that we are getting, is it very good or not. Okay, I'm taking a pause over here. Read till this section and then we'll move ahead. And once you're done reading online, please kindly give me a quick confirmation if everybody is able to understand till this point. क्या हो रहा है? All good? Shall we move ahead? सब लोगों ने पढ़ा? Online, can I get a quick confirmation? Right? Now, we're going to be moving towards the next paragraph or next section over here. Okay, यहाँ पे just see the difference. Conventional model में we know what is independent, what is dependent. Okay, but the main point about conventional model was we know beforehand that independent variable can explain dependent. That is why I'm running a linear regression. Look at this, inputs and features. Okay, suppose I want to predict what is going to be the price of the house in Mumbai, say Andheri location, a particular location. So I will have to give details about the house. When I give data, variety of houses ka data, I'll have to tell him, is it 1 BHK, 2 BHK, size, okay, in terms of square meter, which floor it is, what is the name of the builder, all of these things. These are values or called as feature about the data, which I'm giving to the model. I'm not telling ki the price is going to be dependent on the name of the brand. No, that model will find. But when I'm giving input, it has a lot of features about the data. Like for example, I want to predict the car ka price. Okay, so I'll give the details about the car. Ki kya horsepower hai, how many people hatchback hai ya kya hai, SUV hai. I'll give a lot of feature related data. And finally, I will get the output. Output means the predicted value, which is the forecasted value. And this is also known as label. Okay, mark this as star, label. Okay, this table entirely, pura. But label as a word will again get repeated. That is why. Okay? Now, let us go to the section. This is what we have already covered. What is machine learning? Okay. You can read this paragraph. Read kar lo, please, everybody. So machine learning is a way for computer to learn from data and figure out pattern to solve problem. Okay. A lot of people are now using machine learning to predict where the next crime in the city is going to happen. Based on the data of crime that they have, historical data, they will predict. Machine will predict because of pattern identify karega. Okay. You can read the first paragraph. It can be hard to figure out which thing to look for and how they are connected. Machine learning will help you. Okay. So machine learning will, they need not worry about anything. Data mein kya connection hai, kya hai. Just put the data. Machine will learn. Okay. They will find the connection. That algorithm will find the connection. Okay. These models do not need to worry about how many times it is going to happen, how likely. They are only focusing on the best possible. That means the accuracy. Okay. So if I'm giving you an answer that the next crime is going to happen on this city in this time, or yahan hone wala hai, suppose, how much accurate I can predict. Okay. Obviously 100% to nahi hoga, but accuracy will improve because we'll also validate. We'll go and validate in the history ke same model answer de pa raha hai ki nahi. If the model is able to give the answer which is matching with the history, this ko backtesting bolte hain. Okay. So this is just the same discussion point. I'm just running the PPT over here. Okay, this is what we have covered. We have also covered this. Categories, which we are entering into. This is the main part, main in the sense, it is basically telling you what are the different types of machine learning. With main part is what the method or category is intended to do. Okay, so if you come to this section, there are three broader categories: supervised, unsupervised, reinforced. Whenever you hear the word supervised, now that means when I'm giving the data, I am giving a labeled data. Label means मैं उसको एक specific information दे रहा हूँ. I'm giving a specific information about the part. Okay, you'll understand it as we run the example. First part, supervised learning. Where it is used, this is going to tested in your theoretical question. If I want to predict the value of something, that means what could be the price of the car, what could be the price of the house. Okay, see this market, housing wala market, it depends upon the buyer and seller. Okay, but if suppose there is an app which can tell you what can be the average price of that house in that area based on the historical data, the machine learning is the data is algorithm is learning and telling you कि ये होना चाहिए price average. बराबर? That is what I'm trying to help you understand. So it can help you to predict a value of something, or it can predict the outcome of something, whether you will win the match or not. Who will win the World Cup? Okay, like that. So these are the two broader things that will come under your supervised learning. Either you will predict the value of something or the outcome. Okay. when we hear the word label data, what does it mean? It helps to learn the computer because the data is already aware what is the answer and it can learn from it. It simply means जब मैंने historical data दिया, okay, suppose housing prices का, okay, so I have given all the features of the home, and for each home I have also given what is the price. ये समझा आपको? I'll repeat the example. So suppose if I want to run a model wherein I want the model to predict the next house ka price. So when I'm giving him the historical data, in that historical data, there'll be a lot of features. Features means 1 BHK, 2 BHK, which floor, which city, which location, a lot of features will be there. And I'll also give him what is the price of that data. So it is labeled. So for each house, it knows the price. Samajha? And on the basis of that, using that price information, it is going to predict the future. अगर मैं price नहीं दूं, तो label data नहीं है. Because I have not given him the historical price of the data. ये clear है? Okay. I'll give you more example. Let us come to this part. Now I want you guys to read. थोड़ा PPT read करना पड़ेगा, but it will become easy for you. Suppose a supervised learning. Okay, suppose I want to find the price of the house based on its size, location, number of bedroom. Okay, to train the supervised model, we would gather data of past house sales. Okay, including all of these features. Obviously, जब मैं data डालूंगा, I'm going to put the data. The size of the house will be there, location will be there, and the number of bedroom will be there, and also the price will be there. Okay, and its sale price. The data is called labeled because we know the answer. The answer is also already there in the data. जो sale का price है, that is the answer. So for each data that I'm putting, I'm also giving the answer. ये समझ में आया? Clear? Each data I'm putting, I'm also giving the answer, which is that is why it is called as labeled. And now can you connect back? What was the output? Other name for the output? Label था ना? और इसको बोलते हैं labeled data. तो जो historical data है, whatever that data, historical data that we have, in that already we have the sale price of the home. That label answer is already there. Clear hai na? Okay. And based on this data, the machine learning algorithm will learn and it will predict what is going to be the sale price of the new house. Okay. This is fun example. Second example, spam or no spam. Right now, Google automatically put any email in a spam. वैसे थोड़ी कर रहा है. It is running some logic, right? And every time it is going to learn the new mails that you're getting. It will learn your behavior and it will bifurcate spam or no spam. So whatever activity you're doing on Gmail, it is actually a data set, trading data set for that algorithm. जो हो रहा है. Simple, right? Next. So when suppose I want to bifurcate between the spam or no spam. Okay, so I will have to give the historical data to the model with all the features, mail ka size, with attachment, whom it is coming from, and all of that. And I will also tell the model that this is spam and this is not spam. I will give the answer also in the historical data. Ye clear hai? That is labeled data. On the basis of that, the model will be able to classify spam hai ya nahi hai. This is your supervised learning. I'll take a pause. I'll ask you to read this. The important word is this, labeled. Ek first paragraph read karo. All good? So two things, either you will find the value of the car, value of something, or you will find a prediction or outcome of an event, whether there'll be a win or loss. Clear hai? This is supervised learning. Any confusion, let me know. Okay? Unsupervised learning, from the name, unsupervised means there is no labeled data. Okay? And this is generally used to find pattern or classification. Matlab, my intention is to not predict. Okay, if you're finding a value of something, also you're also doing some kind of prediction. Barabar? When you're finding an outcome of the event, sport event, jeetega, harega IPL, who is going to win, that is also prediction. Over here, my intention is not to predict. Okay, I just want to find if there is any pattern in the data. So that is why there is no outcome which is given in the data. So if you go back to example of housing price, in the data which was given to the model, the price of the house was label. That is also provided. But in this case, I will not provide that because my intention is not to predict. It is to only find the pattern. Clear? One of the example, we might group together some similar kind of data. That means customers who buy same thing from the store. Okay, so, and this is what the Amazon also does. When you're buying anything based on your historical data, they will categorize you as a good customer or a customer who only returns. Okay, so if you're in that category, if you're getting closer to that return category, automatically the time that your delivery time that you're getting is going to be delayed, because they know once you order, within one day you'll cancel. Ye samajh mein aa raha hai? This is happening in real life also. You might not know it. Okay, Zomato, when you open up, automatically it gives you a pop-up. It is all driven by this machine learning. Okay, so over here, unsupervised pattern, it simply means we don't want to do any prediction. We want to find the pattern. Let us look at an example. Look at this. Clustering. Clustering means what? Grouping. Okay, grouping similar customer on their purchasing habit. Now think about this. Suppose you are running a very big restaurant and you have the data of your customer. Based on this, you can identify which is my prime customer who can spend more. So I'll give him a slightly different service, slightly different place to sit, right? Offers will be very different for him because we know he can spend. Certain other customer who just come normally once in a month. So he's a different kind of customer. So I can cluster my customer. This is a very basic example. And on the basis of that, we can take business decision. कि मैं क्या करूँ, उसको offer दूँ या नहीं दूँ. Okay. So for that, we will need the history of the customer data. Okay. So what is the purchase history? That is why when you swipe credit card information, when you swipe a credit card, that information is also sold in the market. Not sold in the sense shared in the market. On the basis of that, they can take decision whether this person is going to buy product or not. Okay? And that is why cred is so huge. Because it has the information of your purchases. जो आप swipe करते हो ना credit card, वो information उसके पास है. That is why. Okay. So if suppose I want to cluster similar customers on the basis of their purchase habit, so I cannot use supervised. I'll have to use unsupervised learning, and because it can find patterns between the customers, their purchase behavior, their spending behavior, and I can create clusters. So that is one example. Second example would be identifying pattern in stock market without any specific target in mind. See, I'm not saying I will buy and I will sell, but I want to find group of companies which behave almost similarly if there is a recession, or group of companies will behave in a certain time. For example, if the RBI is going to increase the rate, certain group of companies will behave similarly in market. So वो information चाहिए मुझे. Then the next step would be whether I will take buy or sell, वो अलग है. But the model is not doing any prediction with any end target. It is just showing you what is the relationship in the data. Clear? You can read this paragraph. Then we'll go to the book. Right? If I open the book, I want everybody to read this small paragraph, unsupervised. Barabar? Now, before we move into reinforcement, I want you guys to read this part and also read this line important, ye internal auditor. So the example is very good. So, and it helps you to identify how unsupervised learning is going to work. If you're going for any audit, you have transactional data, accounting entries. If you put that into the model, and model is going to tell you that these 10,000 entries are suspicious, just focus on that because the behavior is very different. So it helps you in your audit work. That is how they have given you. Okay. It does not tell you कि suspicious hai. It is only saying that the behavior is different. of the entries. Okay, read this paragraph also and read this example properly. Internal audit wala. Right? Sabne pada? Now we'll be moving towards the reinforcement part. Reinforcement from the word. Okay. So if I give a very basic example, suppose if you are preparing for FRM and you decided I will study for 2 hours every single day. You pick up the book. The moment you distract, there'll be a slap. That means a penalty. If you sit for 2 hours, you will get half an hour of Instagram. That is a reward. Okay. So basically reinforcement means you try to give a reward or a penalty. Penalty is generally not there, but a reward. Okay. Which will reinforce that, okay, I have to behave in this manner. Ye samajh mein aaya? So that is not, also you must have seen that if, for example, if you have a maze means bhul bhulaiya, in which if you put a rat, and rat has to now find the final outcome or the doorway to go out. If he is able to reach there, he will get some cheese. So, and again, if you put him, he will recognize after 10-15 times that if I go and find that outcome, I'll get cheese. So there is a reward which is what do you say, helping you to behave in a certain way. Okay. So why we are talking about this? If suppose if I have created a bot which is going to play chess. Okay, so reward could be winning. Okay, so he will first play the chess. He might lose. Okay, but he will keep on playing. He will keep on playing until the time, because he knows I want to reach to that reward. He will set a reward for that, and he will keep on playing, and he will keep on understanding the game in such a way that he will improve his understanding and improve his way of picking the moves. That is how your every model is working. Right? So if you look at ChatGPT also, it has been first trained on huge amount of data, then it is now available to you. So when it must have started 2 years, 3 years back, it must be doing a lot of mistakes in giving answer. But it keeps on giving, and then it moves towards the good one. That is why when they released the ChatGPT, they gave a free version. Now they're charging because they wanted the lot of people, million people to use it, and it will learn from that also. Clear hai? Yahan tak? So what is reinforcement learning? To make decision in changing environment. So when you're playing a game, things will change every single time. So he will keep on learning. He will keep on losing, but he'll keep on learning, and he will refine his understanding. So he will learn through trial and error. Okay. The same example of a mouse in the maze. Okay. So this, if you look at this reinforcement learning, it is more like trial and error approach. And over here takes a lot of time for the model to learn. Okay. And that is how all of these models are being trained. If you see, there is a AI humanoid, naam bhul gaya main, koi Dubai mein hai. That humanoid which is already being trained in that manner. Right now, Aaj Tak is going to bring AI avatar news reporter. Nahi suna, jaake dekho news. So that is also now a next thing that is going to come. Okay. So everything is going to be on the trial and error perspective. Look at this example. So suppose you are teaching a bot to navigate to a maze. Okay. So he will start the process. He will start exploring. Okay. He will hit the wall. Okay. If he finds a dead end, that is a penalty kind of him. If he hits a dead end, or if it's a wall, it's a penalty. If he reaches toward the end, that is actually a reward. Okay. Over time, the model would learn which action will lead to a reward. Reward could be anything. For a robot, it can be you have reached to the end point, or you have come out of that maze. Okay. And gradually he will realize the process of doing better. Okay. So, and that behavior change will help him to do the activity very fast. And this is not only applicable with robots. If scientists have been doing it with rats. So when they put a rat and they put a cheese at the end point, 1 or 2 times he will take 10 seconds, 15 seconds. And gradually, if you keep on sending him again and again, his time reaction will become down to 1 second. He will immediately go to that area because he has learned from that experience. The same thing is happening with machine. Okay. One more example. Suppose if you want AI system to learn chess. Okay. Obviously, he will play against lot of people simultaneously. Okay. When he's winning, he's getting a reward. When he's losing, it's a penalty. So over time, it will learn how to become better at the game. The way we learn. But obviously, unka process fast hai. Okay. This is an example of reinforcement. I would request you guys to read this paragraph and also look at this last paragraph. Then we'll move towards the data preparation and cleaning. All good? This chapter is easy. Itna taklif nahi hai. Okay. So now we are going to be entering into data cleaning. Now, why do we need data cleaning? Because it is not going to be कि I have taken the dump of Twitter, I have taken a dump of any social media or my SMS dump or WhatsApp dump, and I just put it in the algorithm and it will be able to understand. ऐसा नहीं होने वाला है. So I'll have to prepare the data and clean the data. Now, why cleaning is required? A lot of times your data might not be proper. Suppose if I want to talk to somebody on WhatsApp and I want to say your. So it is not YOUR. I would directly write UR. Barabar? This is normally you do in Twitter also. So how system will be able to understand what does this mean? So you have to first of all clean the data and prepare it in certain ways. Okay, so there are certain ways approach that we are going to be looking at. First approach is standardization. Okay, this is nothing but scaling the data. We'll look at the example also. For this, we'll have to look at the example over here. I'm just going to zoom in. Okay, there is a formula which is given in the book also. If you see that formula, which x minus, it's very simple formula. Don't worry about it. Suppose I have information about 10 students, 10 or 16 students. Okay, and they have scores in the exam, certain scores. Okay, the first step I'll do is I'll find the average and the standard deviation of each exam. Okay, I'm doing standardization process. Okay, one more pause over here. Why do we do standardization? One more example. Suppose एक काम करो ना, इसी बंद करो ना कोई. So one more example of standardization. Suppose there is one student who's given an exam with 100 total marks. 100 question tha, he's given the exam, 100 marks. There is one more student who was given 200 marks ka exam. So when you look at the final score, you will not be able to compare, because one student has got 80 out of 100, the other student has got 60 out of 200, or it could be 90 out of 200. So by looking at only the number, you will not be able to understand. That's why we standardize and we create percentage. Barabar, 10th may also, when you go, you look at percentage ideally. Okay, that is what we are trying to do over here. Now, if you look at this section, look at the entire data over here. Okay, the idea is that the data is more or less now in around 0 and 1. Can you see that? -1, 0 ke aspas hai. How do we do the standardization? I'll go to the book now. Can you see this formula? So they are doing it for each data point. Okay, so this is my data point xij. What is this? This is my mean and this is my sigma. And do you realize this is something similar which we were also doing in the z value? What was z value? X minus mu. That was also called standardization. Okay, same process, but we are doing it huge data points. Okay, so how do we calculate? So I have created B2, which is this 85 minus what is my average 83 divided by 4.83. This is a standardization process, right? And I have done it for all the data points, and I can do it for the second section also. This is very easy. The second approach is nothing but it is the normalization. Now, normalization can be done in two ways. I have explained to you both the approach. The first formula is given over here, where they are using minimum value as a reference point. There is also another method which uses the maximum value. Okay, so again, normalization it means things might be very different. You're keep bringing everybody in the same order. Normal kar rahe hain sabko. Okay, so that way Normalization works, and if you look at the formula also, this is minimum and maximum transformation. That means they're using the maximum value in the data, they're using the minimum value in the data to take decision. That is what they're telling you. Okay. And they are creating a variable which is between 0 and 1. This is important, huh? Between 0 and 1. So mark it as star. And see, formula is not very difficult. Obviously, you need to understand ki kya ho raha hai in the formula. Look at the first example. This is my xi, the data point. What is this? The minimum value in the entire data, the maximum value in the entire data minus the minimum. So do you realize this denominator is nothing but a range? What is range? The minimum and the maximum value, kitna gap hai? What is the gap between the minimum and maximum? So it is divided by range. Clear? How do we do it? Okay, suppose if I have data of country and their GDP. Now I cannot compare US ka GDP with Mexico, na? It will be not easy. So I have to normalize the data. And how do I normalize? Obviously, I have first calculated the maximum minimum value. What is maximum value? In the entire, which is the maximum one, I'll take that. In the entire, which is the minimum one, I'll take that. Clear? Next, look at this section. What is the formula? B3, which is this, minus the minimum divided by the range. Range kahan se aa raha hai? The difference between the maximum and minimum. Clear hai? We can do the same thing over here. Now, basically, the data which I had taken, it is already kind of sorted. That is why the first number is coming as 1, because it was the maximum value, right? And the last number is coming as minimum, 0, because it was the minimum value. That is just one way to see it. But if the data is not sorted, you will not get the answer in this order. Clear hai? Focus on the formula. I hope everybody is able to understand what the formula is doing. Okay. Right? And the formula is also given in the book. There's one more way that we can do it, which is the second approach. This is not there in the book. So over here, you just divide by the maximum value. So in the entire data set, I've taken the maximum value. Okay. And I've just taken that value, 32 point something something divided by the maximum value. Now I have changed the data. This is population. Okay. Alag liya hai maine data. But you will again get the answer between 0 and 1. Clear hai? Okay. I'm taking you towards the book. 1 second. I'm asking you guys to read this entire part. This entire part. And let me know if there is any confusion. I hope everybody online is also able to understand the concept, standardization and normalization. You can expect a theory question in this. Next is data cleaning. Okay, why do we need data cleaning? Because if there might be problem with the data, like for example, look at this missing data. Okay, now you're comparing, suppose, height and weight of students. I'm just giving a hypothetical. You have the information of height, but not the weight of one student. You cannot use that data. Either you have to fill the data, okay, or else remove the data. Generally, what we do is, if you want to fill the data, you will take the average weight and you will put it. Ek tarika wo hai. Or else just remove the entire data on that set. Okay. So one of the most common problem that we see is missing data. One of the ways you can remediate is removing the observation or replacing the missing observation with either mean or median. So I have a height of the student, but not the weight. I will take the average weight of the class and I will put it over there. That is one way. Or the median weight and I'll put it over there. Clear? This is one big problem which we have to sort out. Outliers. What is outlier? Extreme value. Suppose if I have a class, all of you guys, okay, there is average weight is around 50. There is one student which is 200 kg. So it is a big outlier, because if I use that outlier, the average will get impacted. So I want to avoid it. So I will do what? I will either generally we remove these outliers. So how do we decide that which is an outlier? So we will say, we'll check the median, or sorry, the mean, and we'll see that from the mean, if anything is about 2 standard deviation above, we'll remove. That is one example. Okay, it is dependent upon you. How do you want to do it? 1 standard deviation, 2 standard deviation, that way. Okay. Duplicate observation, very simple. So if you have customer data, in the customer data, the same customer account information is again there, you will remove the duplicate data. This is very easy, na? But you will find this information, and please understand, this is big data. This is not 1,000, 5,000 entries, million entries only. And from that, first you have to clean. Okay. Inconsistent recording. Inconsistent recording means the numbers are not correct, or the data is not correct. Where the phone number was supposed to be there, the information is with only 5 digits. That is incorrect, right? Or for example, the PIN code was supposed to be there, the mobile number is there. Inconsistency in the data. Or unwanted or relevant observation. So when you look at the entire data of the customer, for example, okay, suppose Amazon Pay people who have purchased. Now, what they have purchased, when they have purchased, all of this information is there. But there might be an extra information that, okay, what is the card number from which they have purchased? If that is not important for me, I'll have to remove. Because, and why it is important for me to remove? Because if I give unnecessary information, it is going to take time for that model to learn. So मैं थोड़ा उसका barrier कम कर रहा हूँ. I'm removing that barrier. ये clear है? So these are the few approaches for cleaning the data. Just have a quick read. I don't expect this to be important for the exam, but आपको broadly पता, because this is common sense, right? Read this section. नहीं बोल सकते कितने आएंगे. आने चाहिए. There definitely will be questions from this chapter, but we cannot predict because we don't have historical data. So, okay, so I cannot identify the pattern. Okay, I'm assuming everybody is being able to read that section. Let us go to the first question fast. Compared to the traditional method, I want everybody online to also answer. Huh? Machine learning provides all of the following benefit except. Does it provide flexibility? Yes. There is no need to scale the data. ये बराबर है. Standardization क्यों कर रहे थे फिर? We have to scale the data, na, because the data might not be good. This will come to this point. Ability to manage large data, that is correct. Capture non-linear, that is correct. My answer is B. Second question, compliance manager at a bank using machine learning to review journal entries posted in the bank's ledger. She is concerned with employee using the long journal entries to be recorded. This is where they are identifying a pattern. Okay, banks use it. Banks use it if there is any abnormal behavior in your account. Every month you do only 2 transactions. Then suddenly every day you are doing 3 transactions. It's a red flag. Red flag in the sense the system will identify. Okay, this is unsupervised learning. Let us go to the principal component analysis. Now from here, slightly things will become interesting. Okay, this was just the basic discussion point. Okay, have you guys heard about this? PCA kahin pe dekha? There is one chapter, modeling non-parallel, bond evaluation, last chapter. In that chapter, there was a principal component analysis. So what is principal component analysis doing? From the name principal, okay? Principal means important. What is component? Variable. Okay, so if I am running a regression, okay, I will try to find how the regression is going to run. I will try to find a very, very important variable. Machine will automatically find which is an important variable, which is explaining my dependent variable. Most, मतलब सबसे ज़्यादा explain कर पा रहा है. Majority of the explanation is coming. That will become my first principal component. Means first independent variable. Suppose it is able to explain say 40% of the dependency. Then we are left with what? 60%. Then the machine will go and find which is the next best independent variable which is able to explain the remaining 60%. Okay, it will go and find that variable that will become my second variable. So first and second, suppose it is able to explain 20%. Okay, what is the remaining? 40% is remaining now, which is not explained by 1 and 2. Barabar? Machine will again go and try to find any variable which is able to explain the remaining 40%. Suppose the third variable is able to explain 10%. So as we do in this process, the first thing that you should be able to identify that the first 3 or 4 components, they will explain majority. Barabar? Majority of the dependency. Okay, but there is one important rule that you have to follow. All of these variables have to be uncorrelated. Now, why do we need uncorrelated? Think logically. When I'm looking at my first independent variable, so everything which is connected to that independent variable, that means everything that independent variable is able to explain, it has no dependency from any other variable. समझ में आ रहा है? It is purely and purely being explained by that independent variable only. Okay, and it is not connected with any other independent variable. That is a very, very important rule. So it is uncorrelated. You'll see that word, uncorrelated components. So when we say principal component, component means the independent variable. Okay, and whichever independent variables we take, all of them have to be uncorrelated. You might get this in theory, the concept, right, Soham? Okay, look at this paragraph, first paragraph. It's a statistical technique generally used in unsupervised learning. Why? Because we don't know which variable is going to explain. Na? Okay, so we generally try to find, there is no labeled data in this. Koi bhi variable ho sakta hai when you give the data in it. Okay, so the one of the approach is PCA. The goal of, read this line properly, the goal of PCA is to produce almost the same amount of information using a small number of uncorrelated. Small number means only the first 3-4 variables are able to explain maximum. Pareto principle 20-80 सुना है? कभी apply किया है? 20% of things will explain 80% of the activity. 20% of your subjects will decide you pass FRM or not. Like that. Okay. So when you have huge amount of data, okay, only focusing on those small independent variables which are uncorrelated, you'll be able to explain maximum thing. You might not be able to explain everything. Huh? The intention is to explain maximum. Okay. Now, why people do it, or why models we are using it? Because PCA helps you to reduce the number of features. What is this feature? Feature over here means independent variables. Then I have, suppose there are hundreds of independent variables which can explain GDP of India. When I run a PCA, I will come to know that, okay, 5 or 6 independent variables are explaining majority. Suppose 80% of the change that is coming in the GDP. So I can focus only on those 8 variables. So PCA as a method, it helps you to reduce the number of clutter that is there in the data, or number of variables which you should focus on. Ye clear hai? First paragraph. Okay. Second paragraph. PCA can also be used to do this yield curve movement. What is this yield curve movement wala thing? Connected to that non-parallel chapter, bond valuation, right? In the bond valuation chapter, our intention was, we had a bond portfolio. We want to protect the bond portfolio. For that, we need to know how the yield curve is going to move. So to understand that, we have to understand the factors. Okay, what are the factors which are going to move the yield curve? We don't know. We can run a PCA which will tell us, okay, these are the 3-4 factors which are going to move the yield curve, which I can focus on and protect myself. Samajh mein aaya? Okay, again, those factors has to be uncorrelated. The observed component should be represents a linear combination of variables, which means in a series, they should be able to explain. Linear combination over here means first variable that you're picking up, it should be the very important variable. Okay, that is why it is able to explain 40% of the dependency. The second variable is the second most important. That is why able to explain 20% of the dependency. So it should go in a linear fashion. कि पहले जिसको पकड़ा वो सबसे important को ही पकड़ा है, right? Second वाले को second important, ऐसी order में you are going. Okay. The two most important explanatory components are parallel shift and the twist. This is a component. मतलब ये, it is explaining what is going to be the change in the yield curve. So few variables are, one variable is parallel shift, one variable is a twist. So they are running a model which is using these two variables as the principal component, which is able to explain the change in the yield curve. Okay. Next, I'm taking a quick pause pehle, asking you to read this section, then we'll move ahead. Read the first two paragraphs. All good. The last part. Okay. Based on the review of 7 treasury, again, we are in the same example, a yield curve. Okay. The first 3 components were responsible for 99% of the overall variation. Now, इस पे tension मत लो, क्या लिखा है 99 क्या है? What they're trying to tell you is, when you use a PC approach, first 3, 4, 5 component will explain majority of the dependency. So if you look at this, 99% of the overall variation in the yield was explained by the first 3 component itself. Okay. So like that, PCA is going to help you to focus on the important components. Right? सब लोग हैं साथ में? Clear? Read that last part also, last paragraph. Then we move towards the K means clustering. This is very interesting. Huh? K means clustering. All good, PCA? Now the K mean clustering, this method is slightly repetitive process. Matlab whatever I'm going to show you now, okay, it is not expected for you to do it in the Excel. They have written down in statements. I'm just showing it to you in the Excel, but this process will not stop over there. It will continue happening. Okay, I'm just showing you one part of that process. Okay? First of all, what is this K? What does this K represents? Okay, it represents how many clusters I want to create. You'll come to know what is cluster. Kya ho raha hai karke, okay? So K represents some cluster, and for each cluster, I want to find the centroid. What is the center of that cluster? Okay, we are talking about unsupervised learning. Okay, now what is this cluster and what is happening? Suppose you have the data of credit card users of India. Okay, now you want to create 10 clusters. 10 cluster means you want to bifurcate the entire population who is having credit card into 10 different categories. Okay, suppose who is a very good customer or a bad customer, like that. You have to bifurcate. So first of all, you need to identify the behavior and then see which customer can fall into which category. Now over here, what we do is, when we look at the behavior, we see how much closer you are to that category. I'm repeating, how much closer you are to that category. But when we are saying how much closer to that category, it means how much closer you are to the center of that category. ये समझ में आया? Okay, simple. I'll give you an example. Suppose you are working in office. Okay, you go for tea breaks during your office time, right? So now company is thinking, which are my good employees, which are my bad employees. I've done 2 clustering. Bad employees, they go for tea breaks 7 times. Okay, you are one of the employee. We'll look at your behavior. So 7 times is the average. Huh? Bad employees are going for tea break 7 times. You are going 5 times. You are very closer. You are a bad employee. समझ में आया? So we'll clear the cluster. We'll find the center of that cluster, average behavior of that cluster. How much closer you are to that? Depending upon that, I will put you in that cluster. Clear? Hai? Some simple, right? Now, I'll show you the example also. But I want everybody to read this first point. And this process will continue. Huh? ऐसा नहीं कि एक बारी I put you into cluster, you will remain in that cluster. No, it can change. So I'll show you the activity. Read this paragraph. Soham, read the paragraph fast. First paragraph, everybody. few things which you must have seen. K cluster means how many clusters I'm creating. Centroid is the center of that cluster. Each data point is allocated to its nearest cluster. Okay. And this is the further part. Then the centroid is recalculated and we'll continue the process. Okay. We'll continue the process. Okay. I'm doing the centroid is recalculated. आएगा थोड़ा एक मिनट hold करना पड़ेगा. Centroid क्या है? Come to this Excel. K cluster. Look at only the first part, huh? This part. Only this much information. इसको थोड़ा एक काम करते हैं. I'll just लोग सुनेंगे नहीं. तो थोड़ा ऐसा कर देते हैं. ठीक है? So we'll only focus on this data. Now what is happening? I have animal, their weight and height. And now first step would be, okay, in the first approach, I will find I want to create 3 cluster. Okay, that is K. In this example, I have decided I will create 3 cluster. But because I've just started the process, I don't know what is the center of that cluster. So I can randomly pick 3 data points and I will say this is the center. So in my example, I have randomly picked elephant, cheetah and turtle as the center of each cluster. You can pick anything. There's no problem. Okay. So everybody is clear. So now look at the calculation. Okay. This is there in your book calculation. What is happening? So look at this. B5 means what? This weight divided by the center. So first category, what was the center? Elephant. Barabar? So I'm saying the cluster, first cluster, the center is what? Elephant. So what is the weight of elephant? That will become the center data point. Na? Means that becomes the average of that cluster. Barabar hai? So do you realize I am finding the deviation from the average? Barabar? And I'm squaring it. Why squaring? Because positive, negative. Right? So look at this. When I'm doing B5 minus what was the center of my cluster? Elephant. What is the weight of elephant? 3000. Barabar? I'm squaring it. Okay? Plus, I'll do the same process for height. What is my height? First, mouse ka height kya hai? 0.1 for example. And what is my center elephant? What is the height of elephant? 3. I'll take the deviation, I'll square it. Ye clear hai? I will do this for every data point. Can you see this? Obviously, when I do for the first time, it is not going to give you a very good result because I have randomly chosen. Barabar? Yahan tak sab log saath mein hai? And we'll do the same process for the second case. Cheetah. Check karo. So do you realize what I'm doing? I'm finding how much distant you're from that average of that cluster. मैं वो cluster से कितना दूर, center of the cluster से कितना दूर हूं. ये समझ में आया? अरे हाँ या ना? इधर चीता एनिमल सब लाया मैं. So I hope everybody is able to understand. So I'll do it for each of them. Now think logically. Look at the first data point. ये वाला data point को देखो. First. Okay. So if you look at mouse, it is very far away from the elephant, matlab the center of the cluster. So I am not in first cluster. Barabar? The second and third. See the third data, I am very much closer to the third data. Matlab third cluster का जो center है मैं उससे बहुत नजदीक हूँ. I am closer to that. So I will fall into the third cluster. ये समझा? That is why I have colored like this. So I will assign a cluster. Can you see the clusters over here? And how did I assign the cluster? Wherever the distance is very small, I'll put it in the cluster. Clear hai yahan tak? Right? Now, when they're saying repeat the process, na, it is written in the recalculate and repeat. Somebody said, na, recalculate. So kindly ignore this for the time being, ye wala part. So once I've got the cluster, now which all animals are in first cluster? Can you guys tell me? Kaun hai? Only elephant. So in first cluster, it is only elephant. Second cluster mein 1, 2, 3. And third cluster mein the remaining one. If somebody asks me, what is the average of that cluster? Now, I have information. So first cluster ka average will be what? Elephant ka data. Straight away. Nothing to worry about. What is going to be the average of the second cluster? Center of the second cluster. So second cluster mein you have these information. Na? So for example, tiger and cheetah is there and this. So I will take the average of these data. How do I calculate? Check. If I want to find the average height of the second cluster, average weight of the second cluster, I will take 180, 80 and this and I will divide by 3. Simple average, barabar? Similarly, I can find this. Clear? Hai? Third cluster, how many people are there in third cluster? So how many animals are there in third cluster? 5 or 6, something, right? So if I want to find the average height of third cluster, so what I will do, I will take all the animals ka height in the third cluster and I will do the average. Check. Can you check? Ye dekho, I have done the average divided by 6. So now this is my new center. I will redo the entire thing now. Ye dekho, I have done the second calculation. Now my center is this. And I will do the entire process of assigning to each category. Dikh raha hai? This is recalculation. I'll keep on doing this till the time my value of the average of the cluster is not changing. It is remaining same. Then I will stop. I hope everybody is able to understand what is the process. K means clustering mein kya ho raha hai. So hum, right? Piche? Pakka na? Everybody online, can I get a quick confirmation? Till now, this K means clustering. Everybody's okay? What is happening? It's very simple. Don't worry. And we will go to this part. I have not touched ye inertia wala part as of now. We'll go to that. But this recalculation means it will keep on doing it. And every time your cluster will change. Okay. And there will be a point where the data will be in such a way that you will be able to identify true cluster of that part. Okay. Elephant kahan hona chahiye in reality. Okay. Now, when we calculated an approach. What was the approach that I did? If I go to this example, can you check this calculation approach? Square root of something, something. This is coming from the approach which is given in the book also. This approach. So there are two approaches, Euclidean and Manhattan. Dono diya hai. Dono approach you can use. I have used the first approach. Now, what was that logic? I'll come to this. Okay. Kindly ignore this diagram for the time being. Come to this section, ye wala part. Okay. Now, in this section, can you see the formula? Do you realize I did the same thing? What I did, I took the value, deviation from the center, usko square kiya. This was for the weight. This was for height. I added and I did a square root also. So I was using this approach to calculate the distance from the center. Clear? Hai? Now, if you do not want to use this formula, you can use the second approach also. Okay. This formula. Okay. Second formula. The first formula kya tha? It is basically only taking two features. In my data, there were only two features, weight and height. Now, suppose there were no two features. There were like 5 features: weight, height, color, kuch bhi. So you have n features, but the process is going to be same. You will say what is the value? What is the value of the center? You will take the deviation, you will square it, and you'll do it for each of the feature and then add it and square root it. Ye samajh mein aaya? Clear hai? Right? So this second formula is nothing different. It is basically saying the example that we saw was 2 features, height and weight. It can be n features, so you'll have to follow the same process for all. Simple. This is the first approach. Okay. Second approach mein, the calculation methodology is changing slightly. Can you see the method? So it is taking absolute value. Absolute value ka difference basically. So if you go to the Excel, so it is nothing but you have to just calculate absolute. Okay. Absolute value of the difference. So I'll take this, then I'll put minus. And what was my average? Elephant na in the first case. So this becomes the first part. Plus, I'll do it for this also, height and 0.1 and 3. And I'll continue. ये बराबर है? So basically what they are doing is there are two approaches to find this, calculate this distance. यही हो रहा है. Okay. So if there are two features, you will do it like this for weight, height, weight and height. If there are m feature, you will do it for this. Okay. So what is this? These two approaches doing? They are basically finding distance between two data points. What are the two data points? It can be the U and center. So if you look at the first approach, Euclidean distance, it is basically a linear approach. वो सीधा सीधा line निकाल रहा है. Now if you read the book, they have referred it as hypotenuse. ये याद है hypotenuse बचपन में किया था. Same. This line is called hypotenuse. So what they are basically telling us is that when you're using the Euclidean approach to find the distance, it is going to find something which is straight line, and you can consider it as an hypotenuse of the triangle. But when you're using a Manhattan, it is basically finding distance like this. It is going like this, it is going like this. So the other two sides of the triangle hai na, that represents the Manhattan approach of finding the difference. मतलब सिंपल में एक सिंपल भाषा में बोलो, अगर आपको कोई बोले कि A और B के बीच में डिस्टेंस निकालना है, एक तरीका है बोलोगे अरे ये है, एक तरीका है ये. So there are two approaches to find the distance, nothing extraordinary. Okay. I'm taking a pause, asking you guys to read this entire section. Mark both the formulas as star. They might not ask you to calculate, because if you must have seen in the Excel, you have to do so much, but you should know what is happening. Okay. Priyanka, answering to your query, if I go to the Excel, the center one cluster is compared to all the data points. Similarly, center two cluster is compared to all the data points. Yes. Read till this point and give me a quick confirmation, everybody online also, that are we good till this point? Kind of, huh? Yes, basically distance वही है ना, variance कितना deviation है आपका, बराबर है. You will have to calculate for each, na? So suppose there is weight. No. That 2 point does not mean कि two features है. It only means where you are standing, where is the center. ऐसा सोचो. The two observation over here means वैसा. तो two feature नहीं है. Feature में क्या होगा? Weight, height, shape, color. That is different. That will impact your this formula, this part. Over here you will find more part, more extended part in the formula. वैसा होगा. Okay. All good. I'm moving ahead. I am assuming everybody online has also been able to read this section, right? Now, we are finding something interesting over here. Inertia. Why inertia is needed? Okay. Acha, coming back to the linear regression to help you understand. When we were doing the OLS estimation, what was the intention of doing that regression? Minimize the SSR, right? So hum minimizes the SSR, or else minimize your summation of E square. That is what the model was giving you as an answer, barabar? And that, if that model is there, then I feel that this model is good enough. Because when your SSR is lower, your R square is better, which means predictive power is better. Over here also, how do we decide which model is doing better? So they have found inertia as a concept. If there is lower value of inertia, what does it mean? There is better cluster fit. What is better cluster fit? The animals ka clustering that we were doing. Okay, if my inertia is very low of the entire process, I will end up, that means I've done the bifurcation properly. That means I've done the clustering properly. Matlab mera model is good. Simple. Okay. Now, look at, we'll read this part. The goal of K method algorithm is to minimize the distance between each observed value and its center. Because if we are able to minimize, we will be able to clearly say na, that your behavior and that cluster behavior is matching. That is why you should get into that cluster. बराबर, right? A model's fit is better when the individual data points are closer to the center. Do you realize it's the same thing when you're learning a linear regression? If the dots are closer, model fit is better. The same thing they're saying. If the difference between the center, the D, what is D? The D means the distance. So you'll take a squared distance. Why squared distance? Because negative, positive, and you do the squaring and you add. Same way you're doing for variance, right? So if you are able to find a very low inertia in a model, you are in a better spot. That means you are in a better, you have already found the answer, or you have found a model which is able to do the clustering better. Clear? Okay. So what is D? It is the distance between that J and its centroid. So do you realize we were also finding the distance only and we were squaring it? Wherever we are able to find the minimized distance, that is where my model is doing good. Clear? Okay. So very low inertia, okay, is good. Okay, but the problem is, again, what was the problem with R square? What was the problem with R square? Barabar. When we increase the variable, multicollinearity nahi, people are saying multicollinearity. No, when we increase the variable, what happens? My degree of freedom goes down. What do we call this? Overfitting. Dots will come and fit the line, right? Sir, dots will come and fit the line. So you will find that the model is very good, but in reality it is not, right? Same problem will happen over here if we increase the cluster. Up suppose I have 100 data points and I have created 90 cluster, 90 groups. So data to kahin na kahin baith hi jayega, right? So if you look at this diagram, what they are saying, if I increase the number of clusters, think of this as number of independent variable in the linear regression. Okay. Automatically my inertia will go down. Can you see the diagram? Which means when I increase my number of independent variable, my R square will go down. Sorry, my R square increase, which is not giving you a right signal. So our approach is we have to find a balance. How many clustering we should do so that it does not impact my model's prediction ability. Logic clear hai ki how the cluster, when the number of clusters are increasing, your inertia will by default go down and you'll feel, our model is very good. In reality, it is not. Okay. So if you read this section, okay, I want everyone to read this entire part and look at this diagram also, read till this section, then we'll move ahead. Everybody online, please read this. All good? Mark this part as star, this diagram is star, and this paragraph is star. Basically, this is explaining you the core logic. And they just given you a name elbow. Elbow point means where we can stop. Suppose this point. One more point which I missed talking about. So if you're going to increase the number of cluster, okay, the inertia is going to go down, but the change in the inertia, matlab the benefit which we are getting by adding new cluster is very, very slow. Matlab kam ho raha hai. So that elbow point will tell you that it is written over here, when inertia starts to decline at a slower pace, which means when I'm adding new clusters, I'm not getting that much amount of benefit. It is like this: marginal utility theory. You eat the first orange, you get benefit. Second orange, the benefit reduce. Okay. So the reduction is going to happen. The benefit that you get by doing more cluster, the benefit is going to get reduced. So we have to stop there. Okay. That is your elbow point. Or that is where the balance between your number of cluster and the model fit is there. Where's that? Okay. I missed talking about it initially. Ye point, ye paragraph star are important for the exam. Let us go further. Acha, 1 second. Just to choose K. Acha, this is slightly complicated process. I was reading about this online. So basically what happens is, if suppose, okay, till now in the K clustering method, what I was doing, suppose if I am talking about this example, I'm talking about mouse. So if I take the weight of mouse, I will compare it with the center of my cluster. Okay, that I will do. Okay, the first step. Okay, and in this approach, which is this next one, which is given in the book, if you read this line also, distance between an observation, the value weight of the mouse, and other point in its own cluster, I will do that. Plus, I will also do what is my distance to other data point in the next cluster. Matlab, how much far I am from my center in which cluster I am sitting. I will take that information and I will also look at the information of how much far I am away from the other clusters also. The data in the other cluster, and I will compare. So thoda sa complicated part hai. That's the reason I'm not, in the PPT also I've not covered it in detail. Okay. So highest still out score will, kya, bahut complicated kiya. There's no need for you to focus on this. Basically what they're saying is that it will help you to identify how many clusters you should have. Okay. So every time when you add a cluster, you run this process and see whether you are getting a very high score or not. Okay. Will produce the optimal K. When you get the highest score, that means you have to stop. So if I add 5 cluster, I'll get a score. If I add 6 cluster, I'll get a score. I'll keep on calculating for number of cluster. Whichever cluster is giving me the highest, I will stop. I will say, I will only go for 4 clusters. This is just an approach to identify how many clusters are needed. Okay. Read this section. Let us go to the questions part. The end goal of the principal component analysis is the use of which of the following to manage dimensionality. Dimensionality means how many components I'm going to use. What is the end goal? Do I want to find large number of variables or do I want to find small number of variables? Okay, small number of variables ideally. And the important part was uncorrelated. So small number of variables are uncorrelated. That should be your answer. Okay, next part, the optimal number of centroids can be found by choosing what? Centroid over here means cluster. Because the centroid is the center of that cluster. Okay. Where should I find? Which approach should give me the answer? Where the value, the inertia is the lowest possible. That will give you the appropriate number of centroids. Okay. Matlab sabse lowest value hai wo, or else where the change in the inertia is very low. If you go to this point, I'll just take a pause. Read this. Where the inertia starts to decline at a slower pace. This is where we have to stop now. So if you look at the point number D gives you the answer. So most likely student will pick this, but that is not correct. Everybody's clear, na? Question kya hai? Online. Next part, overfitting, underfitting. Very, very simple concept. This is a repeat from your regression. And acha, you guys have heard about variance bias trade-off? ये है curriculum में है. पढ़ा होगा कभी? Okay, same chapter, regression में ही है. It is there. So the same concept, because we are talking about any model which is able to explain the concept. Okay, so the next module that we are going to be talking about, the first part of the chapter module is underfitting and the overfitting. What is overfitting? Suppose if I increase, I'll give you the example of linear regression. If I increase my number of independent variable into the model, what is going to happen? The degree of freedom will go down. The degree of freedom goes down, the dots will come closer to the line. Okay, and my model will look very good. So when the degree of freedom goes down, your standard error will also be looking slower. R square will look better. Okay. Which indirectly means your model is looking very good, but in reality, the model is not good, because when you do prediction, when you do out of the sample prediction, something external data you take and you try to do the prediction, you will realize that the model is not doing good. So only reason why your R square was very high, because the number of independent variable increased and your degree of freedom went down. Barabar hai? That is overfitting. So if you create complex model, okay, then you will be at a greater risk of finding that of facing the overfitting point. Okay, so if you create too complex, too large, or too many parameter, okay, you will actually face the problem, which is a lot of machine learning models generally they face as compared to conventional, because over here the machine learning model is choosing the independent variable on their own most of the time. So if suppose they created a model and they told you that, okay, GDP of India can be explained by these 1,000 variables. What is the point? First of all, you will not be able to use it. Second, because there are so many variables, the model will give you a very good answer, because you need 1,000 inputs to get the answer of GDP. But in reality, you will not be able to do the same thing for the prediction part, or you might not be able to get that same accuracy. Okay, what is overfitted models are doing? Read this line properly, and I am marking this as star. Overfitted models are evident when new data causes the model to perform worse. What does it mean? If I have used a particular set of sample in my model, that is my in-sample data. When I use external data, some new data points, that is my out of the sample data. When I use the external data point and I try to do the prediction, my error is big. Which is like this. If I want to show it to you in graphical terms, this was my model. The dots were very close to each other. Okay. And if suppose I pick up a new independent, new value of the independent variable, suppose this X. Okay. And I get the answer as this, where the error is very big, but the model was showing that everybody is closer. This is forecasting error. So when you did a new forecasting, you took the new value of X. Okay. Suppose this is my temperature and this is my sales of ice cream. If I take the new value of X, okay, a new value of temperature, and try to predict what is going to be my sale, the value is very far away from my Y hat, which is nothing but my predicted part. Y hat was the predicted part, barabar, right? So that is nothing but telling you that model will perform bad when you use it for forecasting. Okay. So when you're, how do we resolve this? Kaise sort out kare? So this approach, which is also going to be the second part of this module, there is something called training data. Okay. There is something called validation data. There is something called testing data. Okay. Testing set basically. So all of these things can be used to improve your model. Okay. Basically, kya ho raha hai? If you have the entire data set, I'll give you a very basic intuition. If you have a full data set, suppose this was the data that was available, you said, okay, we will use this data to train the model and this one to validate the model. Validate means to check whether the model is giving you the right answer or not. Ye samjha? If you have a full data set, certain part is used as an in-sample data to create the model or to train the model. And then certain part is kept as a validation part, where we are going to check whether the model is giving you some good prediction or not. Okay. Iske baad ek aur hota hai, testing. We'll come to that. Now this point, model construction incorporates training data set. Basically, training data set is the data which has gone into the model. And on the basis of that, it is able to find B0, B1, parameters, coefficient. Barabar? So model parameters over here means the coefficient. So if you remember when I was doing the Excel pe linear regression, okay, so you gave the data, you run the regression, Excel is showing you B0 and B1. From where it is getting that B0, B1? From that sample data that you have inputted. That is your training data. Clear? The validation data set is validation from the name. You're validating whether the model is doing proper or not. It is basically to evaluate the performance on a separate data set, a new data set. उस पे हम चेक कर रहे हैं कि मॉडल चल रहा है कि नहीं, जो आंसर आना चाहिए वो आ रहा है कि नहीं. यहाँ तक ठीक है? If suppose your model is overfitted, what is going to happen when you do the validation? You will find errors, right? So look at it, the output of an overfitted model. Read the line properly, and I'm marking this also a star. The output of the overfitted model, the training set, is going to give you very low error, but a poor performance when you're applying the training set outside. मतलब क्या है? When you are comparing the model with your in sample data, in sample means the training data जिस पे model बन रहा है, you will find very low error. That is why the dots are closer to the line, na? Yes or no? Right? But the moment you do the prediction power is going to be very poor. That is what is your, when you're validating, you're getting errors in the validation data set. Clear hai? I'm going purposely slow. Read this paragraph. Overfitting, please read this paragraph. Yes, Viraj, we're going to be doing M-fold also. वो M-fold वाला logic है इसमें. All good? Aditya, answering to your query, when you use the out of the sample data, your error part means your yi and your y hat is going to be very away, far away from each other, which means your r square will be very low in your out of the sample data, but in your in sample data, your r square is going to be very high. ये clear है ना? सबको मैं आगे बढ़ रहा हूँ. Okay. Underfitting. What is overfitting? What was overfitting? कि you have taken so many independent variables. In underfitting, you have not taken enough independent variables for the model to actually run or understand. Okay. Look at this. When a model is too simple or fail to capture the relevant pattern, matlab you have taken only one or two independent variables to talk about something which is very complex. So model will be there, but it will not give you a good answer. That is underfitting. So there are two problems that you are facing. How many independent variables should we put? If I put more, it will lead to overfitting. If I put low, it will fit to underfitting. Barabar? Right? So to understand this, expected performance of an hedge fund relative to its size. Okay, size over here means how much is the asset under management. AUM. Okay. So that is the asset under management given of their operation. So basically they're comparing what was the performance of the hedge fund when you're comparing it with the AUM that you have for the fund. An expected outcome would be quadratic. What is quadratic? Curve. Quadratic equation dekha hai? So when you create a graphical representation of it, it comes as a non-linear behavior. It is not linear like we were looking at in the previous section. Okay. So with small, what does this quadratic means? With small funds struggling to cover the cost and the larger funds struggling to implement timely strategy. What does this mean? ये line का मतलब क्या है? अगर even if you're not reading this chapter, think logically. If I am Reliance, very big company, the decision making will be very slow. I'll become more bureaucratic because one person will take a decision, he will pass it on to somebody else. He will think, he will put, and till the time it is implemented in the ground, it is going to take a lot of time. Startups may immediate firing, immediate decision. So when you're lean, when you're small, you can take decision very fast. Big companies cannot take decision. Barabar? But the problem with smaller company is their business is very small. So when we talk about hedge funds, they have very small capital, small number of customers. So they will not be able to cover the cost itself. Big companies, they will have huge customer. They'll be able to cover the cost, but the decision making is very slow. Ye samjha? Right? A machine learning model would ideally try to capture this non-linear relationship, which a conventional model will not be able to do it, because we started talking about this now. Conventional model generally focus on linear behavior, but non-linear ke liye you have to run a specific models. Okay, if you are not sure how the data relationship is going to be, you can focus on the machine learning model. Okay, and what is this underfitting of the data? There is a greater risk of underfitting in conventional model. Why? Because see why there is a greater risk in conventional model, because if suppose the real behavior was non-linear, And in the conventional model, I assumed linearity and I run the model. क्या होगा? Errors will be big, which represents underfitting. You have not taken right variables. You're not running a right model. So overfitting in overfitting, the errors were being very small. In underfitting, the errors will be very big because you have not taken the proper variables in the model. यहाँ तक ठीक है? Okay. Read this paragraph also. Everybody please read this paragraph. Now the core part of this discussion, which is this bias variance trade-off. Mark this entire part as double star. Now what is happening? Ekdam simple, don't worry. Ekdam simple concept. Okay, we'll go to the first problem that we identified. What was this? Overfitting. So when we talk about overfitting, okay, I'm going to bifurcate bias and variance. When we talk about overfitting, what was happening? You have taken so many variables into the model. Okay, so now there is no biasness from the user. Biasness kab aayega? When I'm saying this is not an important variable. This is not an important variable. Remove it. But when you're taking so many variables into the model, there is no biasness of the user जो run कर रहा है. ये समझा आपको? Okay. So when you are doing, when we are talking about overfitting, the biasness is very low. Okay, but variance is going to be very high. What is variance? When you do the prediction, the distance between the actual value and what your model is saying is very high. The variance is going to be very high for prediction. Ye samjha? Right? That is for overfitting model. The second point, which is underfitting. Now think about this. In underfitting, biasness should be high or low. Why? Because I'm taking only one or two factors. So what is going to happen? It depends upon the user now to decide which factor will go into the model. If I am biased, I feel this variable I will not take. I have some problem with the variable. I have some past experience and I'm not going to take. So that is a biasness which I am bringing into the model. So in this case, my biasness is going to be very high. Okay. But the variance is going to be very low. Why variance will be low? Because I might be able to choose variables. Okay. Think about this. There is no R square wala problem. Na? Degree of freedom is not going down because you're taking very few variables. Degree of freedom not going down. Your R square is by default not pushing up. Right? So overfitting wala situation ho hi nahi raha hai because we are taking very few variables. So when you do the prediction, the gap will be smaller. Okay. So now there is a catch 22 for you. How should we do it? If we create a model which is overfitted, okay, you will find the biasness is very low. But when you do the prediction, the variance is going to be very high. So biasness is very low. Variance is going to be very high. That means the model might not perform well. When you do a model with a very few variables, you are facing an underfitting problem where the biasness is going to be very high. How you choose a particular variable, but the variance will be comparatively lower. So you are facing all of these 2 points. Now I want to choose the number of variable in such a way which will lower the overfitting problem also or the underfitting problem also, which means I want to choose it in such a way which will bring lower value of biasness and lower value of variance, both. Samjha? So I have to put those many number of independent variable, which will bring the biasness error lower, which will bring the variance error lower. If I go to the book, look at this diagram. So this black line is a total error. Okay, look at the other one. This is my variance. This is my biasness. Okay, complexity. Now look at logically. If I reduce my complexity, what is going to happen? If I reduce my complexity, will it be overfitted or underfitted? Underfitted, na? If I reduce the complexity of the model online, if I reduce the complexity of the model, it is going to be what? Underfitted. I'm sitting over here. So when I'm facing that underfitting, which problem will be higher, bias or variance? Right? So can you see the bias is very high and the variance is very low? When I increase the complexity of the model, that means I take more and more variables into the model. What is going to happen? My variance will be higher and my biasness will be lower. But my intention is to find an optimal point where both of them are kind of lower. Okay, so see, this can be an interaction point, but depends upon how you want to choose. Okay, because I also want to reduce, look at this, total error. Now, one interesting point that you can see from the diagram, look at this. Ideally, they should have chosen this point, na? But do you realize this point is not leading to the overall reduction in the error part? Overall reduction kahan ho raha hai? It is happening over here. That is why I am okay to take this much amount of variance error, this much amount of biasness error. Ye logic here, that is the optimal point. Obviously, I want to reduce both of them, but my overall goal is to reduce the overall error also. Because my overall error goes down, the model becomes more good. Clear? I'm taking one more pause, asking you guys to look at this section, this entire part, and then we'll move ahead. Addition of both, na? Bias and the variance. दोनों का ऐड करोगे तो वो आएगा total. Priyanka, the lowest error, the total lowest error is going to be this. Look at this line, this red line. जहां पे सबसे नीचे आ रहा है, that is the lowest error. And if you look at this y-axis, I think so you're asking this y-axis represents whether the error is high or low. So high error, low error. Okay. Mark this diagram as star, important variance, bias variance trade-off. And to understand this, you have to be very clear what is overfitted and what is underfitted. नहीं तो नहीं कर पाओगे. Okay. Now, how do we sort this problem? How do we sort this problem? Training, validation, and test data. Training, validation, and test data. Okay. So basically, what is happening in a very simple language? Whatever total data that I had, I will bifurcate into 3 different parts. Okay. And I will use 3 different parts for testing, for training my models. Okay. We'll do each one of them properly now. So first point, look at this first part of the data. Training. This is the model. This is the part of the data which we'll give to the model. Model uske upar learn karega. It will start learning. Okay. That, and it will develop parameters also. Parameter means, if you remember your linear regression, B0, B1, these were your sample parameters or basically sample points, which came out because you gave the data to the model, right? So this training set is used to develop the parameters of the model. Okay, this represents the data used by the machine learning model to learn how to represent the data. So for example, if you want the machine learning model to do prediction, okay, about who's going to win the next IPL match, so you will have to give the entire data of the IPL, historical data, and with the win labeled one, and then on the basis of that data he will learn. Okay, but when you look at the entire history, you will not give the entire history, you will give say only 5 years, 6 year ka data, and you will ask him to learn on that 5 year, 6 year only. Okay, the remaining data point you will use to do prediction, to check whether the model is correct or not. अगर लॉजिकली सोचो, अगर आपने सारा का सारा डेटा उसको ट्रेन करने में लगा दिया, आपको ये कैसे पता चलेगा कि मॉडल सही आंसर दे रहा है? उसके लिए भी तो आपके पास कोई डेटा होना चाहिए ना, जिसमें आपको दिख रहा है कि चेन्नई सुपर किंग हैज वन एंड द मॉडल इज आल्सो सेइंग चेन्नई सुपर किंग, तभी तो आप वेरीफाई कर पाओगे. तो वैलिडेशन इज वेरी वेरी इंपॉर्टेंट. Okay, so you will not use the entire data, you will use certain set of data which is going to be the first data set to train the data, to run the model. Okay, next is validation. Decide between the 2 alternative models. Okay, this data can no longer be used once the superior model has been chosen. Now why they have used 2 models? Basically they're saying, if suppose I want to identify who's going to win the next IPL match, I might have created 10 models. Every model is giving the answer. But when I have I will run the validation ka data. I will run each 10 of the models on the validation data to check which model is giving me the right answer. So I will choose the model. This is the result they are giving from the validation data. Right. So over here they have taken two models. I can take 5 models also. Okay. So basically they are saying I will compare the results and from the validation data, और उसके बाद I will decide which model to go ahead with. ये clear है? Okay. Next part. Testing set. This is something which we did not talk explicitly. Okay. So we only spoke about training and validation till now. If you read the previous part also, there was one reference of that. Okay. This is the testing effectiveness of the model. यहाँ पे generalization. Okay. ये basically saying that whether the model is actually in reality facing any overfitting, underfitting problem or not. Whether the goodness of fit, what is goodness of fit? Whether your model is doing good or not. बराबर? Whether it is genuine or not. ये check करने के लिए you also have some set of data on which you will again test the model and then you will deploy it for usage. Okay, I'll read the line again. A model is effective when the fit of the test sample is almost good as the fit of the training sample. Which means, see, training data and testing data. Okay, both of them are giving you the similar kind of answer. That means your model is good. Because you trained the data and you tested also, the answer is almost similar. There is no variation. Because if there is variation, that means the error is going to be big. Barabar hai na? Logic. Okay. Now, all of this, why are we doing? Because we want to make sure that whenever the model goes and does a prediction, okay, using out of the sample data, it should not fall flat. It should give you a good answer. Barabar? So that is why we want to make sure that whenever a sample out of the model is used, the sample out of the model means hold out data. Okay. Now, ये hold out data का मतलब क्या है? एकदम सिंपल भाषा में समझाता हूँ. मेरे पास IPL का 10 साल का डेटा है. उसमें से ट्रेनिंग के लिए मैंने 7 साल का डेटा लिया. 3 साल मैंने होल्ड करके रखा है. समझा? ये है वो होल्ड आउट डेटा. सिंपल. Okay. Everybody? Why am I holding some data? Because I want to test the model on that data. To test the fitted model. बराबर? The goal is to see basically वही है कि unseen observations के सामने वो कैसे behave करता है. तो मतलब क्या है? If I am looking at 10-year IPL data, 7 year, I have trained the model. So model has seen everything which has happened in that 7 year. So now when I take the remaining 3 years and I test the data, this is an unobserved situation for him. So I want to see how it is going to behave unobserved. So this is a training environment for you. When you go to exam, unobserved, unique behavior. That is where you perform. Okay. Clear hai yahan tak? I'm taking a pause for this entire section. Yahan tak. Read this section and then we'll move ahead. You're almost done. Khatam hone ke liye. Kindly read, everybody, please read this section. Let us move forward. Now we are going to move into M-fold logic. Kuch M-fold karke kuch hai, but it is very simple. Don't worry. Okay. Now, although there is no set allocation for how much a given sample would go to the respective data above, a typical allocation of 2/3. ये जो दिख रहा है 2/3, 1/3. What is this? What they are saying is, if I have this much data available with me, this is the IPL 10-year का data. How will I decide how much is going for the training, how much is going for validation, how much is going for testing? Okay, so if you read the logic over here, 2/3 generally goes for the training. Okay, 1/6 goes for validation, and the other 1/6 goes for testing. मतलब क्या है? This part, training, is 2/3. What is the remaining? 1/3. Okay, तो 1/3 को भी 2 parts में divide कर दिया. Okay, this is my validation and this is my testing. There is no set rule, but normally this is what is followed. Okay, clear hai? So this paragraph basically tells you that how do we go about finding, okay, how much should be allocated to training, how much should be allocated to validation, how much should be allocated to testing. Now the problem that you might face, okay, suppose you did not give enough data to training, मॉडल बकवास आएगा, राइट ना, उसको ट्रेन का डेटा ही नहीं दिया आपने, एक प्रॉब्लम वो हो सकता है. Second problem could be the training data was very good, but there is nothing left for validation. That is another problem. Okay, so read this line. Biasness in parameter estimation are a risk. I am marking this as star. Are a risk associated with small training data set. मतलब मॉडल को सीखने का टाइम ही नहीं मिला. It is basically preparing for 3 days and going for the exam. You have not learned, na? Model सीखा ही नहीं. Okay, while inaccurate model estimation are risk of small validation. What is this? You have read and read and read, you have learned a lot, you have been trained, but you did not give the exam. There is no validation whether you have understood or not. Logic समझा? सब FRM exam connect करो, सब समझ में आए. ठीक है? Read this paragraph please everybody. Online, please read the paragraph everybody. Concept is very simple. खाली लिखा ऐसा है कि आपको लगेगा कि क्या हो रहा है करके. Okay, coming to this next paragraph. Okay, what they have talked about two things: cross-sectional and time series. Time series, so you have already seen, na? Stationary time series, non-stationary time series. If I take sales ka data and month-on-month sales ka data, that is time series data. Okay, so if you look at this cross-sectional data point, there is no natural order in which the three sets can be placed. Okay, इसका मतलब क्या है? There is no sequence in the data. Okay, उसका मतलब suppose if I give a video of any film, okay, to any model, so the initial part of the film, suppose model film is for 2 hours. Okay, so first 1 hour the model is going to watch the video and train itself. बराबर है? And the validation part or the testing part is going to be the end, na? Because why are we showing this video to the model? Because we want the model to predict the climax. अब वो तो लास्ट में आने वाला है. तो आपको लॉजिक समझ रहा है? What they are saying is, if it is a time series data, there is going to be a natural order. मतलब I'll show it to you. Very simple logic. ये देखो, this is my entire movie. Okay, I have divided the entire movie into 3 parts and I want the model to train on predicting the climax of the movie. Now the climax is over here, ना? अब मैं इस डेटा को लेके ट्रेन नहीं करा सकता. लॉजिकल ना? I want this as a validation or testing data. इस पे तो चेक होगा कि उसने राइट क्लाइमैक्स दिया कि नहीं दिया. अगर मैं इसी पे ट्रेन कर दूंगा तो क्या लॉजिक है? बराबर? So there is a natural order, which means that the training set is going to be the first part of the movie. There will be some part of the movie which is going to be validating, and then it is going to be testing part. It is in a particular order. You cannot use the last part of the movie to train. When there is a natural sequence, that is time series data, where there is a natural sequence and you have to follow particular order to give the training, give the validation, give the testing. But if there is no natural sequence, आप कोई भी data उठा सकते हो, like IPL data. Last 10-year data, you can take the latest 3-year data to train the model. ये भी हो सकता है. So when there is no order, it is called as cross-sectional. Simple. Read this point. I hope everybody online is clear on that paragraph, cross-sectional and time series data. आगे बढ़े. Now, यहाँ से, what is the problem that they are identifying? We said we will create training validation, but if there is no enough data, then what will you do? Okay, the larger the data set, the lower the risk of improper allocation, because if you have huge amount of data, okay, suppose 10,000 data points. So if suppose out of that 10,000, I'll just write it down over here. Suppose this entire data is 10,000 data points, and the training ke liye you have taken say 7,000. Now instead of 7,000, you took 6,900, 6,500. It will not create much of a problem because there is enough data on the other side. Okay, so your risk of incorrect allocation to training, validation, or testing is very low when the data is very big. Barabar? But if the data size is very small, then you will face a problem. Then this approach called as K-fold cross validation can help you. Okay, so how do we do it? Okay, look at this. This technique, suppose, okay, read this. This technique combines trading and validation into a single sample. See, we talked about training, validation, and testing. We are saying कि training and validation एक साथ हो जाएगा. पहले हम क्या कर रहे थे? We were bifurcating. Now we are saying कि दोनों चीजें एक ही बार में हो जाएंगी. ट्रेन होके हम वैलिडेट भी कर लेंगे उसको अंदर ही. ये हो रहा है. Simple. Because the data is not available. Right? Next point. Okay. So now they have used K sample and N allocation. Okay. Very, very simple. Don't worry. A common choice is K of 5 or 10. Now, if the K is 10, okay, not necessary कि हर बार 5 or 10 होगा. Common choice बोल रहा है. Okay. Now, if the K is 10, that means I'm dividing the data into 10 parts. Okay. And what I will do is, I'll show it to you graphically. This is suppose my 100 data set. 100 data points available है. Now I'm saying कि I will bifurcate into जो भी 10 है, देख लोगे 10 है, मैंने create नहीं किया है. This is your 10 data set. इसमें I will have to repeat the process again and again and again. Okay. Look at this first point. The data will be divided into 10 randomly selected some sample of equivalent size. So 10%, 10%, 10%, 10%, barabar. The first estimation would be from K1 to K9. What does it mean? Let us assume this is my K1 and this last one is K10. मतलब 10th part, barabar. So first time what I will do is I will use K1 से लेके K9, sorry K9 तक as my training and validation data. I will leave this 10th as a testing site. बराबर है? Right? Second time मैं क्या कर सकता हूँ? I will take, say for example, from K2 to K10 and I will take this as a testing. I'll keep on doing this. मतलब हर एक बार एक एक को निकालूंगा, उसको टेस्टिंग के लिए यूज करूंगा, बाकी सबको ट्रेनिंग के लिए यूज करूंगा. I'll keep on repeating. बराबर? So do you realize 10 times my model is getting very validated? ये समझ में आया लॉजिक? Everybody is clear? I'm repeating, एकदम simple concept है. You have created 10 buckets. Okay. When you're doing the first time model, when you're running the model for the first time, you're giving K1 to K9 to train the model and K10, the last piece, to validate or basically test the model. We'll do the entire process again, but this time suppose I'm taking K2 to K10 for training and K1 for testing. Similarly, I can do for anything else and remove say K3 for testing. Likewise, barabar? That is happening over here. So if I read this, okay, the first estimation would be K1 to K9 and keeping K10, which is a hold down, मतलब मैं hold करके रखा है. Okay, this is reserved for testing. एक तरीका ये है. First time I'll do this. Second time what I'll do? I'll do from K1 to K8, okay, with and K10, but I'll remove K9. मतलब एक निकाल दिया भाई. K1 से लेके K8 भी लिया, K10 भी लिया. I have removed K9 and I have used K9 as a testing. So 10 times the model is going to get tested. बराबर? Pakka na? So this creates 10 validation sample. 10 times the model will get validated in different samples. बराबर कि नहीं? And I will basically average the performance of all the 10 and I will say this is the performance of the model. ये क्यों कर रहे हैं? Because sample कम है. Logic clear है? थोड़ा सा कंफ्यूजिंग लिखा है बट कॉन्सेप्ट बहुत सिंपल है. ये एक प्रॉब्लम है. ओके, वी आर मूविंग अहेड. अगर सैंपल और भी कम है, दिख रहा है लीव आउट क्रॉस वैलिडेशन, अ स्मॉल नंबर ऑफ ऑब्जर्वेशन पॉइंट में बेनिफिट फ्रॉम अ लार्जर के सेक्शन. अब बहुत बार ऐसा होता है कि आपके पास सैंपल ही बहुत कम है, आप ये रिपीट भी नहीं कर पाओगे इतने अच्छे से. सो व्हाट यू विल डू इज, सपोज आई हैव 10 सैंपल, ओनली 10 सैंपल. So I will create 10 cluster, matlab 10 buckets. So my K and my N will match. If I go to this, do you see K is equal to N? What was K? How many buckets I am creating? K1, K2, K3. What was my N? Total data point. So if my data is very, very small, I'll do the same thing, same process जो मैंने पहले किया था, but bucket उतने ही हो रहे जितने मेरे N है, because the data points are very small. Okay. Where the number of folds is equal to the number of data points. This is one more way of doing the solution. Okay, I'll take a pause, read this section. Okay, read this entire section, then we'll move toward the quiz part. One second. Kindly read that paragraph. सबने पढ़ा? I'm just quickly asking you to read this PPT थोड़ा सा. Okay, almost similar but थोड़ा सा you'll get a good understanding. Suppose if I have, why are we using cross K fold cross validation? Suppose I have 100 toys. 100 toys over means N. Okay, so if the data is very big, you can have 2/3 of the toys as training, 1/6 of the toys as validation, 1/6 of the toys as testing, for the model to learn from it. Okay, and we will verify it. But look at this. If you do not have enough toys to do good training, validation and data set, then you can use this K-fold validation जो हमने अभी देखा. The first approach, बराबर? Okay, what was the first approach? You can read this. Suppose I have only 20 data, 20 toys. So what I will do, I'll split them into 3 sets. Okay, 3 sets. You can divide them into 10 random groups. Acha, sorry, the 3 sets छोड़ दो. 10 random groups. Why 10? Because if you remember in the book also it was written normally you take K as 5 or 10. Okay, so if your K is 10, then your each group will have 2 toys. Barabar? And so what you will do, out of the 10 group, you will take 9 group as well testing, training, and 1 group which is left for testing. Okay, and you will repeat this process 10 times. Okay, so that each group can be used in the validation process. Same जो मैंने किया वही हो रहा है. Right? Okay, the purpose, because we have very small number of toys, 20 only, and we want to utilize everything. We don't want to waste any toy in training the model. The further part, look at this, leave out one cross validation. Okay, so in this case, look at this example. Suppose I have 4 observations, 20 million, now we have only 4. Okay, and each observation I'm getting color as an information and diameter as an information. So now over here, if you remember this leave one out cross validation may, you have K is equal to N, which means if I have 4 observation, I will create 4 groups itself because I cannot create 10 logically. Barabar? So I've created 4-fold. 4, if you remember in the previous part, it was written as M-fold, 4-fold. Okay. Each one of them containing one observation. How will the process work? This is not given in the book. Okay. This is the last approach, the leave one out approach. Okay. For the first fold, what we are going to be doing, we'll use the first observation, okay, to test, and observation 2, 3, and 4 as training. Matlab kya hai? How many data points that I have? I have 4 data points for the 4 toys. For example, I have created this as first fold. Okay, so K1, this as K2, this as K3, this as K4. We are using the same logic. I'm going to use this as training first time, and this will become my testing. Right? I will repeat the process. Read this. Okay, we will repeat the process for the remaining 3 folds also, leaving one out of observation at a time, using the remaining observation as a training. Matlab each fold we are doing it. Okay. The only difference between this approach and the previous approach is that over here the K is equal to M. In the previous approach, we were also doing the same thing. Certain parts को आपने train किया, एक part को छोड़ दिया, वो test कर रहा था, बराबर है, right? लेकिन वो एक part के अंदर कितने भी toys हो सकते थे. यहाँ पे एक part में it is only one toy, because your K is equal to N. ये समझ रहा है? That is a major difference. Okay. When you are done for all the observation, okay, we will take the average. Generally, we take the average of all of the models, the validation that we did, and that will become the accuracy of the model. Okay. So this basically helps you to use the minimum 4 data ko you have been able to use it properly to do the training, also to do the validation also. Again, remember, why are we doing it? Because we have very small number of data points to do the training, validation and testing. All good? I hope अब सब लोग थोड़ा समझ में आ रहा है क्या हो रहा है. Okay, look at this. अगर आ रहा है तो बताओ. We will test. This is the testing. Okay, the prediction that is, everybody online please, prediction that are generated from an underrated model. अगर underrated model है तो क्या होगा? High variance and low biasness. High biasness, low variance. C part, बराबर? High biasness, low variance. वो diagram जाके देख सकते हैं, बराबर? Analyst is choosing between 2 machine learning models. Which of the following data set will the analyst most likely use to make the determination which model to select? क्या लगता है? Validation set. ये main set है जिसपे आप validate करते हो whether ये model. If you remember in the book also it was written. If you read the validation point, read this. 2 models, out of that 2 I am going to select. एक बार आपने 2 मॉडल में से एक को सिलेक्ट किया, फिर वो प्रिडिक्शन के लिए यूज किया था इन द टेस्टिंग. ओके, सो आंसर इज गोइंग टू बी डी. आंसर इज गोइंग टू बी डी. द लास्ट पार्ट ऑफ द चैप्टर थोड़ा सा सहल. रीइंफोर्समेंट लर्निंग. विल कंप्लीट दिस फास्ट. रीइंफोर्समेंट लर्निंग मींस व्हाट? यू हैव, देयर इज गोइंग टू बी अ रिवॉर्ड, देयर इज गोइंग टू बी अ पेनल्टी. सो रोबोट इज इन द मेज, इट इज लर्निंग. What is the penalty? Not able to find the door and also hitting the wall. That is a penalty. What is the reward? You are able to find the door. Okay. So it is more generally used when you want to play the games. Okay. A systematic approach involving trial and error. We talked about this at the start. Okay. Where a computer keeps on playing, keeps on learning. Okay. Every time it plays, and it helps you to take better decisions. So this is also the way trading happens. So when we say algo trading, algo को थोड़ी मालूम है खरीदना कब है, बेचना कब है. So it is basically trained on the training data set in such a way that by learning it, it has now been deployed in the market. So when your derivative hedging, trading rules, all of these are done because they have been extensively trained in that kind of environment. If you do not have data, you will not be able to train. Reinforcement learning नहीं हो पाएगा. Okay. Simulation games. Okay, normally when you see that robot is playing chess or it is playing football, तो वो वही है. It is happening because of that. Okay. Now, when you are looking at the reinforcement learning, there are 3 important sections over here: environment, action, and the reward. Okay. Now over here, they are doing some calculation as such. Okay, now I don't expect in the exam they will ask you calculation as point, but what is this calculation basically telling you? So think about this. The model, there is a robot in which it has to take a decision whether it will go and buy an asset or sell an asset. Okay, it has two decisions to make, buy or sell. So for each decision, it will calculate something. That calculation is happening over here. Okay, and whichever decision is giving you the maximum value, okay, you'll choose that. Same चीज आप रियल लाइफ में करते हो. बस पकड़ू या ट्रेन पकड़ू, आपको जल्दी पहुंचना है. Okay, so you'll pick up train because it will give you maximum benefit. So you took a decision to go for train. The same thing system is going to do. So system is going to calculate, and wherever the calculation is giving you the maximum value, okay, that part it is going to take as a decision. I will go for train or I will buy an asset. समझा? ये हो रहा है उसमें. Okay, we'll come to this, but first let us quickly look at the example. Look at this example. Okay, let us say we have a robot that needs to pick up a colored ball from a basket. Okay, the robot does not know which ball to pick up, so it needs to learn by trying different action. Okay, so every time you will give some information, he will pick up a ball and he'll say, no, this is wrong. आपने बोला blue, उसने किसी और को उठाया, will pick up wrong. So he'll keep on learning, right? So every time he is going to receive some feedback. Okay, that is nothing but a reward for him to improve. Okay, and basis that he will try to understand which is a red ball, which is a blue ball, which is a square shape, okay, which is a circle, like that. Okay, so over here, what is the state? The content of the basket, that means the environment on which the model is actually learning. Basket के अंदर जो ball है वो आपका state है, मैं book से connect कर रहा हूँ. Okay, what is the action that he is doing? Action which is the step that the model is doing, using. वो pick up कर रहा है एक ball. That is the action he is taking. Whether that action is going to be correct or wrong. अगर correct है तो he'll get a reward. Wrong है, he'll get a penalty. Okay, so the reward is going to be whether the robot has picked the correct ball or not. अब यही चीज आपके बुक में दी है in terms of A, your S and R. Simple है. Okay, initially the robot is going to pick wrong balls, obviously, right? आप भी जब छोटे थे तो सब थोड़ी right, वो क्या था बच्चे वाला खेलते थे ना, आपने नहीं खेला? आता ना वो सर्कल्स को इसमें डालो, बॉक्स में डालो, हाँ, तो आप थोड़ी राइट उसमें करते थे. तो सेम वे द मॉडल इज आल्सो लर्निंग. ओके, एंड if it will keep on learning based on the reward, and every time it will improve itself so that it can reach to the final part. Okay, Q value, what is this Q value? Now ये Q value कहाँ से आ रहा है? दिख रहा है ये वाला part. Okay, this is an important part in the robot's mind on the basis of which it is taking a decision. क्या चीज लेना है? Which step I have to take? Okay, so if I go to this part, what is my Q value? Okay, so let us see that the robot is selecting a colored ball example again. The Q value is the score that the robot gives to each action. Okay, it can take in a particular situation, because हर बार तो same information नहीं आने वाली है उसको, right? आपने first time information दिया, pick up a red ball. Second time information बोला, pick up a bigger ball. So every time the information is going to be different. So how he is going to take a decision in each part? Okay, for example, if a robot in a certain position sees a red ball and a blue ball, it will decide which one to pick. But how will it decide? For each time it will calculate the Q value. Calculate करेगा Q value. Okay, the Q value of picking the red ball will be based on certain factors. क्या reward है, क्या नहीं है, basically. And the robot will, if suppose the successful हो गया, okay, if suppose I had asked him to pick up a red ball and he picked up the red ball, so obviously he'll get a reward point. If he picked up a wrong ball, so he'll get a negative point. So basically he will continuously learn and update its Q value. Information को update करते जाएगा. Okay, next part. So he knows this part. He knows if he's going to select a wrong ball, there'll be a penalty. If he select a right ball, there'll be a reward for him. So robot calculates Q value for both the option, and whichever option is going to give him the highest value, which will maximize the benefit for him, he will choose that. So first time he does it, he might be wrong. तो सीखेगा. कि कहां पे चूज करने से रिवॉर्ड ज्यादा मिल रहा है. सो यू विल लर्न अकॉर्डिंगली. बराबर? अरे हो कि नहीं? ओके. क्यू वैल्यू हेल्प्स द रोबोट. प्लीज बी विद मी. थोड़ा सा पार्ट बताए. Q value helps the robot to make the best decision based on the information it has, and it can get the most reward and avoid penalty. Obviously, every time you will not want to have the penalty, but you have to take a decision. You don't know when it is going to be right or wrong. The same thing is going to happen with your in the exam. When you're in front of a question, you don't know what is this question. You'll pick up A, B, C, D. If you pick the right one, मतलब एक तो reward, नहीं तो penalty. Now the same thing might have happened when you're solving the question bank. तो आपने उस पर ट्रेन कर करके एग्जाम में राइट चूज कर लिया. समझा? लास्ट पार्ट. The robot plays more and more games, he learns more and more experience, and he will keep on improving his Q value estimate or the way of calculating Q value. Okay, and that will help him to make a better decision. yahan tak theek hai? This was just to help you understand the concept. Okay, so if you read this part, what is happening when you're calculating Q, you're taking what is the state and what is the action that I'm getting. Okay, in which situation what action I'm taking will maximize my benefit. बराबर है? Simple. Next part, to determine. Now this is very simple. Exploration and exploitation. You can understand this over here. Example देखो. सबका ध्यान. Example. Let us say a robot is picking up a green ball. It will give him a reward of 10 points, 10 positive. If it while picking up a blue ball, it gets a reward of 5 points. The robot is currently in a state where it can see both green and a blue ball. Now, obviously, it is going to take a decision. Okay, so he will see. ये लॉजिक अब मैं आपको तुम बेसिक पॉइंट पे लेके जा रहा हूँ. प्लीज वहां ध्यान देना. He knows there is a blue ball, there is a red ball. He is not sure कि ये blue ही है, ये red ही है, green ही है. So either he can explore it or either he can, मतलब बोलते ना, या तो उसको यूज करेगा इंफॉर्मेशन को या तो छोड़ देगा. So there are two terms over here. Exploit करेगा या फिर explore करेगा. Okay, explore करने का मतलब क्या? He will take chances. Exploit करने का मतलब है जो पहले से इंफॉर्मेशन अवेलेबल थी ना, उसी को ही यूज कर लिया. मतलब I'll give you a simple example. You want to go to office. Suppose there is one normal way which you have been using historically. आप वो रास्ता पकड़ोगे 10 मिनट में ऑफिस पहुंच जाओगे. So you are exploiting the previous information that you have. But there is one more way. You don't know क्या होने वाला है. जल्दी भी पहुंच सकते हो, लेट भी पहुंच सकते हो. You can explore that also. अभी समझ में आया? The model or what do you say? The robot is going to take the decision like that. Okay, either he will explore or either he will exploit. ठीक है? Look at this. So I'm rereading the line. So green ball select किया तो red है, blue ball select किया तो 5 है. If the robot choose to exploit what it already knows, this rasta will take me to office, right? It will pick up the green ball because it has the higher value. बराबर? Right? If he feels, you know, I have already taken green balls every single time, let me try and pick up the blue ball. That is where I am doing something different. Okay, this is explore part. So instead of picking up the green ball, even though he knows it might get plus 10, you might explore and you might go into a new point or new area. Okay, कोई गेम शो देखा है? 3 दरवाजे होते हैं, 3 दरवाजे में एक चूज करना है. आपको शॉर्ट पता रहता है कि इसमें ये मिलने वाला है. तो क्या आप उसको एक्सप्लॉइट करोगे या बाकी जो 2 दरवाजे उसमें जाके एक्सप्लोर करोगे? ये वो हो रहा है. समझ में आया? ओके, so we are calculating the probability. Probability of exploitation is P and exploitation क्या होगा? बचा हुआ ना, 1 minus P. Okay, so as the robot is learning, every single time it is updating those probabilities and it will help him to take better decision. ये हो रहा है. ये सेम चीज आप भी करते हो, ऐसा कुछ एक्स्ट्राऑर्डिनरी नहीं है. Okay, I'm taking a pause, asking you guys to read this section and then we'll move ahead. All good? Almost done. Natural language is very simple. Okay, next part. We are going to move towards this part, Monte Carlo method. Okay. Now, basically, see, when we were looking at states, state matlab kya hai? Situation. Okay. In how many situations the model is going to learn from, right? So if you look at basket, उसमें balls हैं. Okay. तो वो balls को कितना understand कर पाएगा वो? तो only certain number of balls are available. वो उसी में से learn करेगा. Okay, but if you look at Monte Carlo simulation, if you understand from the previous chapters, what was happening, you give variety of situations. Over here also, when you use this approach, the state that the model is going to look at is going to be variety. सब लोग हैं साथ में? एक मिनट भाई. We'll take a break. वो ऐसे भी ध्यान नहीं दे रहे. Okay, guys, we are going to be continuing with this discussion. So we talked about the last concept, which is exploitation and exploration part, which is done by the model. There was P and 1 minus P also. Now we are going to be moving towards the next section, which is going to be the Monte Carlo method, or is a temporal difference learning method. For this, we'll have to go towards the presentation. Okay. So first part, Monte Carlo process. Now read this line. Imagine that the robot is trying to decide which ball to pick based on the color of the ball and the position of other balls. Okay, the Monte Carlo simulation will simulate many different scenarios. The same thing which we will also learning in the simulation chapter in book 2. Okay, it will create different scenarios where the robot will make different choices and see what the reward it gets. So basically, hypothetically, we'll create scenarios, okay, or called as states. State kya tha? Environment on which the robot was making action, and then it will decide, the action will decide whether it is going to get a reward or not, right? So we'll simulate those states or those scenarios, okay, and then we'll keep on doing it for 10,000 times or million times, and it will then be used to find which action is actually leading to highest reward in different situation. And on the basis of that, you will create your mindset that I have to choose this action. The robot will create a mindset that I have to choose this action. So on the basis of the performance that you're getting on the variety of situation, so robot ने ये ball पकड़ा या कुछ और अलग shape का है पकड़ा, कुछ जो भी मतलब उसके साथ scenario हुआ, उसमें every time whether he's getting a reward or a penalty. Okay, so robot has seen so many simulations, and then on the basis of that, you will take a decision that okay, this is the right approach for me to take the step or take the action based on the simulations that I've undergone. Okay, now in this, you will use some parameter, some module for alpha. Okay, alpha is generally 0.01 or 0.05. This is basically an adjustment that you do. The model, the robot is making an adjustment every time the new scenario is coming and improving itself. So that adjustment is driven by alpha. Okay, so it will adjust its behavior over time. That is your Monte Carlo approach. So if I go towards this part, okay, don't worry about this calculation. This is not important ideally. See, this part is basically saying that I have some old Q value. Okay. And can you see the alpha over here? Alpha is the adjustment part. So think of it like this. You had some old understanding. Okay. Some new scenario came in. You learned from that scenario. Now, whatever old understanding you had, you are updating that. Right. So old Q value is updated with some new information, and that adjustment that you're doing is alpha. Okay, and now your Q value is now getting updated, and this is your new Q value. Means your robot's understanding is improving. So robot has an old understanding, which is old Q. Some new scenario happened. Either he will get a reward or either he will get a penalty. On the basis of that, he will update his old Q and create a new Q. That is a value. I hope you remember Q was what? On the basis of the Q, you will take a decision what step you have to take, because you will always take a decision to maximize the Q. Barabar? The same logic. The second approach or an alternative approach is this, okay, which is called as temporal difference learning method. This method assumes that the best strategy for the robot is the one that has worked well in the past and only looking at one decision ahead. That means in this case, the exploration is going to be very, very low. You'll always exploit, you'll always try to exploit your historical part. what it simply means, think of this like ऐसे सोचो कि you have to bet, you're a robot and now you have to bet who is going to win. Okay, so based on historical data you felt ke okay, I will bet on India. Okay, you bet on India, Pakistan won. Wrong ho gaya. So in this temporal method, what you're going to do is whatever was the latest information, latest part that happened with you. Acha, last time I bet for India, Pakistan jeet gaya. So next time when the same match is happening, you'll bet for Pakistan. Because last time Pakistan jeeta tha. You got the idea? So you're basically you're not taking very extreme decisions. What you're doing is whatever last has happened with you, you're keeping that in your memory and you're taking decision accordingly. Simple. That is this part. So robot has a good memory in the sense past experience jitna bhi hoga. I have taken an example of only one match. कि last match में जो हुआ था उसके basis पे will take the decision, बराबर? But suppose the robot is taking last 3 matches, and on the basis of that it is taking decision to choose Pakistan. ये भी हो सकता है. Okay, so basically in this case the robot is keeping some memory, and on the basis of that it is taking a decision. Okay, in the previous part or in the Monte Carlo approach it was constantly updating, बराबर? तो जो भी आपका information है decision making लेने का, the Q value was constantly getting updated. Clear? Read these 2 paragraphs, please, everybody. And then we'll move towards the calculation piece. I hope everybody has read. Now, they have given you an example of this part, the new Q value. क्या हो रहा है देखो. There is a table which talks about your historical Q value. Okay, मतलब current Q value, which is also called as old Q value. Okay, on the basis of that you can take a decision, or you have already taken a decision. You can think of this like that. Now action 3, I'm taking the same example. Action 3, state 4. Can you see this number? So 0.5 was my original Q. Okay, now suppose you are going towards a new situation. You're looking at a new situation. In that, an alpha, let us assume your alpha is what? It is given over here, 0.01. Okay, and this in the new situation, the reward point is 1.2. मतलब अगर नए सिचुएशन को मैंने सक्सेसफुली टैकल कर दिया तो मुझे 1.2 का रिवॉर्ड मिलेगा. ओके, Q जो है that is my ability to take decision. Okay, now what is happening? Can you see this calculation? What is this calculation? यहाँ पे जो हो रहा था वही है. What was your old Q? 0.5 plus what is the adjustment? 0.01. Next, how much far you are from that reward? So my reward is 1.2. You are away from it because your current value is 0.5. Okay, this will give you the new Q. Barabar? What is the value? It is calculated 0.507. Right? Now, do you realize your initial value was 0.5? This was my old Q. From here, I have moved to this new Q, which is 0.507. Can you see this? I have adjusted from this to this value, 0.05. Similarly, look at the second situation. If the next decision to be made is in state 3, okay, I'll change the color. If the next decision that I'm taking is state 3, and assume that the reward earned between the 2 decisions is 0.3. Okay, so state 3 में ये है 0.8 है, old one. Okay, what is my alpha? 0.01. the difference between the difference method between the result Q4 and Q3. What is this Q4 and Q3? ये किसी को समझा? यहाँ पे देखो रेफरेंस है, स्टेट 4 एक्शन 3, राइट? ये दिख रहा है, ये नंबर जो हमने भी कैलकुलेट किया था. सब लोग हैं साथ में? ओके, दिस इज जस्ट अ वे टू हाईलाइट कि क्या हो रहा है. ओके, नाउ दिस इज द सेकंड स्टेप. द फर्स्ट स्टेप वाज दिस. In the first step, what happened? I had an initial Q value of 0.5 because of the new reward point. Reward point was 1.2. My Q value got updated and my new Q value is 0.507. यहाँ तक सब ठीक है? Okay. Now look at this. यहाँ पे क्या हो रहा है? The original Q value is taken. Okay. This is my alpha and this 0.8 और ये जो नया आ रहा है ना, this is a difference between this state and this state. दिख रहा है आपको? तो मतलब ऐसा है कि लास्ट टाइम स्टेट 4, हाँ, लास्ट टाइम स्टेट 4 वाज अ सिचुएशन and you had taken action 3, sorry, action 4, sorry, action 3, my bad. And now the situation is changing to state 3. Okay, so pehle you were here and now you are moving to state 3. Okay, the same action is happening. Okay, so obviously now your behavior should change because situation change हो चुका है, बराबर? You lying in front of your friend and lying in front of your manager, implication is different ना? तो जिस situation में रहोगे आपका situation change होगा, implication भी उतना ही अलग आएगा, बराबर? So over here what is happening? Okay, I am moving from the old data, मतलब old state 4 to state 3. So basically I'm taking this difference 0.8 to 0.5. What is this difference? This is the difference between the state. Same action पे आपको दोनों अलग अलग करते हो कि आपके Q वैल्यू में कितना डिफरेंस है, आपके डिसीजन मेकिंग में कितना डिफरेंस है. That is happening over here. Clear? Next part, you're also taking an effect over here, which is this is the reward point which is given over here. The rest of the process is almost same. Okay, rest of the process is almost same. The only thing is कि आप reward point को include करके अपने ये वाले वैल्यू को ओरिजिनल 5 को चेंज कर रहे हो. ओके, तो ये बेसिकली बता रहा है कि अगर सपोज देखिए, अच्छा, आई विल रिफ्रेज द एंटायर एग्जांपल अगेन. जो हमने फर्स्ट सिचुएशन देखा उसमें क्या हो रहा है कि अगर स्टेट 4 हो गया होता, स्टेट 4 में थर्ड एक्शन हुआ होता, ओके, और उसी में अगर मैंने रिवॉर्ड पॉइंट चेंज कर दिया होता, सेम सिचुएशन वापस आती और अगर आप सेम एक्शन लेते तो क्या होता? आपका क्यू वैल्यू अपडेट हो जाता. ये समझा आपको? राइट? अब सेकंड एग्जांपल जो चल रहा है ना यहाँ पे, इसमें उन्होंने सिचुएशन को चेंज कर दिया. व्हाट दे टोल्ड यू इज दैट द स्टेट एक्शन इज सेम बट द स्टेट हैज चेंज्ड, सो योर कैलकुलेशन इज नाउ गेटिंग चेंज्ड. यू कैन नॉट यूज द सेम कैलकुलेशन बिकॉज यू आर मूविंग विद इन द स्टेट. तो वो जो डिफरेंस है ना बिटवीन द स्टेट वो लिया जा रहा है, दैट इज 0.8 एंड डिफरेंस बिटवीन 0.8 एंड 0.5, ये लिया जा रहा है इफेक्टिवली. ओके, आई एम टेकिंग अ पॉज, asking you guys to read this entire section, look at the table also properly. All good? Now the last two lines over here, what they're simply doing is they're telling you how do we got this table? Okay, because when you're starting, there's no table, there is no information. So you can run other models like deep learning and neural networks to get the basic information about the table. And then if you're on the basis of the table, you will keep on updating the information. So last two line is just to help you understand the table आया कहाँ से. Okay. NLP basically क्या है? This is also used in your chatbots. Okay. So it tries to learn, analyze your human language. It can be written, it can be verbal also. And on the basis of that, it will give you an answer. किसी ने कोटक बैंक कॉल किया? क्या कोटक बैंक का एक AI चैटबॉट है. IVR कॉल पे AI आपको बताना पड़ता है क्या प्रॉब्लम है, क्रेडिट कार्ड. Voice based, not only your chat based. Chatbot to everywhere is there, no? But on a IVR, when you call up, you have to the AI will ask what is your problem. So you have to tell credit card. On the basis of that, it will analyze. It will give you 3 more things. तो आपको बोलना पड़ेगा ये है first, yes, ये point है. On the basis of that, it will update. So over here, what they are doing, they are analyzing human voice or human language, either written or heard one. Okay. So NLP is widely used in text mining. Okay. Because if there is an accounting fraud, okay, or suppose if the data, okay, if suppose I give you an entire document and I tell you what is the tone of the data. Is it friendly? Is it inspiring? Is it angry? How will you come to know? Is it very sad? So by reading that data, the model will understand that behavior because वो read कर रहा है human language को, how we are interpreting it. Okay. So accounting fraud and detection में भी they values को लिया जा रहा है. Value मतलब what is written. I'm not talking about numbers. I'm talking about suppose a accounting entry has happened or a transaction entry has happened in that there is a name. Okay. So he will be able to read that name and make sense out of that name. कि ये कोई customer है क्या या कोई vendor है मेरा, like that. Okay. Next is assessing the sentiment of a corporate statement or comment. ये generally अभी implement होगा when you go and put comment on your social media handle of companies. Suppose now you have tagged Tesla. Okay. And on the basis of that you have made a comment. तो AI will decide कि ये इसके ऊपर action लेना है कि नहीं लेना है. मतलब ये positive comment है, negative comment है, like that. No human will sit and analyze it. Okay. Right now people are doing it. Next is categorizing text. Categorizing text means is this a poetry? Is this a normal statement? Like that. Recognizing specific words for determining the purpose of the message. This is generally happens in your intelligence. फोन उठाओ 4 बार बोलो बॉम्ब, FBI सीधा घर पे, राइट. तो जो controversial words हैं, if you use that word, automatically people will come and assess you. तो वो क्यों हो रहा है? Because the system is analyzing it. It has a pattern of the threat words. Okay, same thing. So this is basically giving you a speed when you're analyzing a huge amount of data, huge telephonic conversations happening. Now, when you're looking at your company chats, internal chats, उसमें कुछ discussion हो रहा है, that you can analyze easily. Okay, which your humans cannot find it because human might have biasness. Obviously, मेरे टीम का कोई data है, मेरे टीम में कोई चोर है, तो I will not identify it. There is a biasness involved, ना? या फिर मेरा ही chat है, तो मैं थोड़ी बताऊंगा. There is a biasness involved, and there might be a lot of inconsistency also, na? I'll make mistake when I'm doing an analysis. So humans cannot do it. NLP will help you to do it. Okay. Next, how does NLP process the data? अब उसका एक पूरा steps that they follow, and I want you to remember this, marking this a star. The first part. So what it will do is, and I have written down it in the example also. I'll just quickly take you. Take 1 second. You can read this slide. NLP is about teaching computers to understand the language human use. Okay, like when we write or speak to each other, it is useful because it is a quickly looking through a lot of written information or find certain part of the information and take a decision. For example, if you want to teach the computer, the first step that you'll have to do is whatever sentences we have, we'll have to break up words into text of smaller pieces, और वो एक-एक piece को हम क्या बोलते हैं? Tokens. Okay. Also, Next thing will be all the tokens will be written in lowercase. This is important. Okay. This, and why is this done? If you suppose go and code in Python, you cannot have space in between. जो आप लिख रहे हो उसमें. It is the way the algorithm is designed. Okay. So you're keeping it in lower space so that there is no confusion in reading, because if it is one letter is uppercase, उसका उतना ही calculation बढ़ जाएगा. बराबर? So everybody is kept in lower, but individual words are now called tokens. And if you go to the book, this is the first step, tokenization. Okay, which identifies only the words. मतलब if there is a sentence, okay, I am going to the market, so I go to the market. सबको एक अलग-अलग bifurcate किया. Okay, and everybody is bifurcated into lower cases. बराबर? The next part, then we remove some common words which does not add any value. Like for example, the and. मतलब computer is not facing any problem in reading those. It is, these are repetitive words. Again, why am I removing it? Because when I'm going to analyze it, it is going to consume my energy. So मैं इसको निकाल रहा हूँ. Okay, the second step is to remove the common words. Okay, that is nothing but over here, stop words. The, has, a, which is not changing the meaning of the letter. Okay, which has no value. So we'll have to remove those words. Then we will also change the words to their most basic form. Okay, like changing arguing, argued, argue into this. मतलब क्या है? When obviously I was arguing with you, or I argued with him, ultimately the main theme is I argue हुआ. बराबर ना? So computer will not get tangled in that word ना कि ing है, ed है. We'll just say कि हाँ argue, that something happened, and he knows the meaning of argue. Okay, that is called stamping and lemmatization. Basically, you are making sure that the data which is going to the computer, it is simple. Okay, there is no repetition, there is no unnecessary things. That stamping is over here. Clear? देखो ये दोनों मैंने एक ही में explain कर दिया है. Okay, so what is happening over here? Stems का मतलब क्या है? These three words, arguing, argued, argues, all of this is being converted into one single word. Next, lemmatization. See, for example, worse maps to be bad. What does it mean? Worse मतलब ये हो रहा है ना कि अगर I am not in good health, I might say the same thing in some other slang language. I'm not keeping up, something like that. तो वो word को they will map. Okay, so that it becomes easy for the computer to understand. So what is happening? It is similar to stamping, but you're mapping the verse as a word to bad word, and it is not every time. It's not going to be synonym. Huh? It is basically the way we talk. ये समझ में आया? Say for example, somebody might call his father Papa, Dad, Pop. हाँ ऐसे बुलाते हैं. तो this is our way of talking, ना? So uska you have to map. It is means the same person. Likewise, okay? That is over here. And finally, we might look for a group of words that might appear together and give them a special name. जैसे for example दिख रहा है ये एक token है. This is first token, second token, third token. Each word, and when you club these words, it means something. Going market, ये दो word, मतलब I'm going to market. Likewise, and that logic I will have to club, and this is also happening over here. Anagram. Okay, anagram में क्या हो रहा है देखो, we are creating a group of word. Okay, जैसे ये example है, each one of them are individual token. Okay, यहाँ पे ना order doesn't matter. Basically ये तीनों चीजें एक साथ आ गई. It means something. That is how the computer is reading it. Okay, and then the main part is this bag of word. This is also important. Mark it as star. Okay, bag of word. Basically क्या हो रहा है? You can think of this as कि all the words, relevant words, are put in a bag. That is why they have referred it in this manner, where the order and the linkage of word is irrelevant. Which means, suppose मैंने ये तीनों word exceed analyst expectation. Company has exceeded analyst expectation. ओके जब ये तीनों वर्ड साथ में आ रहा है, इट इनडायरेक्टली मीन्स आई एम टॉकिंग अबाउट सम कंपनी, ओके, और उसने अच्छा परफॉर्म कर दिया, तो ये तीनों वर्ड को एक बैग में डाल दिया, ऐसा सोचो। ओके तो ये बैग जब भी पिकअप हो रहा है, मतलब ये तीनों चीज जब भी पिकअप हो रही है, इट मीन्स दिस थिंग कि कंपनी हैज परफॉर्म बेटर। ओके सो इन दिस केस ऑर्डर बिकम्स इररिलेवेंट, मतलब अगर डेटा के अंदर पहले एक्सीड आ गया या बाद पहले एक्सपेक्टेशन आ गया, कंप्यूटर विल रीड इट दैट वे। ओके आई एम टेकिंग अ पॉज, asking you guys to read this entire section, then we'll move ahead. All good? Last, should I move towards the last part? So how does NLP, how is NLP used? Okay, for example, there is a corporate news which is being released. Okay, and you will take a decision on the basis of this positive, negative या neutral. इसका मैं example बताता हूँ. बहुत time पहले there was this algorithm which is used in the market to take a decision to buy or sell. Algorithm trading जो होती है ना, so algorithm trading में it will use data from some authenticated source. For example, Bloomberg information, or else Twitter handle of lot of these. White House का Twitter handle है. Okay, तो ये algorithm is taking data from some strong authenticated source, and then it will, whatever tweet has happened or whatever information has happened, it will take a decision whether this information is positive, negative or neutral. Positive he will go and buy, negative he will go and sell. बराबर है? So sometime back what happened, your White House का Twitter handle was hacked, and there was a news or the tweet happened that there is a bomb blast in White House, and automatically the market reacted, market started selling because algorithms were selling. The logic समझा? So whenever that tweet happened, the algorithms picked up that tweet and they analyzed it whether it is positive information, negative, or it's a neutral information, and based on that they started selling it. Clear? Using an inventory of sentiment words. Okay, sentiment word means we can easily predefine and classify it. कि good, positive word है, negative word है. Okay, likewise, or neutral word है. Now, why do we need this? Because when you have a, suppose your information, press release है company का, you will find how many good words are there, or how many positive words are there, how many negative words, and you can decide what is the tone of that entire news. Okay, example of negative word stems are concern, disappointment, decrease, decline. दिख रहा है? So when you are sitting for your appraisal and your manager is using all of these words, it automatically means what? Hike nahi milega. Right? So you can understand the tone. Likewise. Next part, in a situation where a news release may have 4 positive words and 6 negative words, okay, the sentiment of the overall piece could be established as negative. मतलब एक डेटा के अंदर, एक शीट के अंदर, फॉर एग्जांपल द कंपनी इंफॉर्मेशन, जो उसने पॉजिटिव वर्ड डिसाइड किया था, नेगेटिव वर्ड डिसाइड किया था, नेगेटिव वर्ड की संख्या ज्यादा है, तो आपने बोला ओवरऑल टोन नेगेटिव है. सिंपल. अ चैलेंज इज दिस, ये देखो, ये वाला इंटरेस्टिंग पार्ट है कि कभी कभी लिखा अलग तरीके से आता है वर्ड्स को. ओके, सी अ चैलेंज इज टू हाउ टू हैंडल सिचुएशन वेयर अ पॉजिटिव वर्ड आर फाउंड इन सेंटेंसेस व्हिच आर नेगेटिव इन कॉनोटेशन. ओके, जैसे आप घर पे, जैसे आप, मैं एक बेसिक एग्जांपल दे रहा हूँ, आप लेट उठते हो कभी सुबह, तो आपकी मम्मी या डैड कुछ ताना मारते हैं, राइट? वो होता पॉजिटिव है लेकिन दिया जाता है नेगेटिव सेंस, राइट? तो वो आपको, वो कंप्यूटर नहीं समझ पाएगा. ओके, वुड हैव रिजल्टेड इन एन इंक्रीज, वुड हैव रिजल्टेड इन एन इंक्रीज, मतलब अगर आपने पढ़ाई कर लिया होता तो आप पास हो जाते. पास आ गया वर्ड, लेकिन द टोन वाज वेरी डिफरेंट. So such kind of things cannot, your model still cannot understand it. So for that you need human review to refine and tell the model that this is wrong analysis. यहाँ तक ठीक है? I'm taking a pause, asking you guys to read this section. Kindly read till this part and then we'll move ahead. Sarcasm, yes. Sarcasm, positive or negative. Right? Let us go to this question. Analyst is applying a reinforcement model and assigned a probability of exploitation as 65%. So exploration क्या होगा? 35 पक्का? Expect the probability will increase above. अच्छा sorry ये क्या है? As she completes more trial. What is going to? अच्छा मैंने पूरा नहीं पढ़ा था, sorry. Exploitation होगा ये. She reasonably expect that the probability will increase above what? हाँ 65% से ऊपर जाएगा ना, because the more trained I am, the more chances that my probability of exploitation will increase, which means I'll be more confident that यही pick करना है because of my base knowledge. So answer has to be B, na? 65% of probability that will increase. NLP is used to, what is this MDA? Every balance sheet or every annual report has a section जहाँ पे management talks about what happened last year, how they see in the next future, क्या होने वाला है, what is the growth of the industry. So you can read this, system will read this analysis and they will make some judgment about the annual report. Okay. In removing the stop word, the NLP algorithm will remove all of the following except pollen. ये negative word आ गया ना, ये नहीं होना चाहिए. Okay. All of these others are the stop words. Right. So we are done with this chapter.